Time out. Are we live, like broadcasting live too? Okay, just wanted to make sure. All right, go.
3, 2.
Hey everyone, we are live here in Valencia, Spain for KubeCon, Cloud Native Con, and we're coming to you right from the show floor. Well, I don't know if you can tell because the cameras are facing this way, but we have people all around us here. It's pretty cool. This is our first interview of what I hope will be many over the next 2 days, and we're thrilled you're joining us if you can't be here in person. Our first interview today is with some folks at Sysdig, and let me introduce you to Michaela.
Correct.
And Loris. Loris, why don't you introduce yourself to the audience?
Sure, my name is Loris De Giovanni. I'm a CTO and founder at Sysdig.
And Michaela?
I work with Loris at Sysdig. I take care of leading the open source engineering efforts.
Absolutely, and we're going to jump into the open source stuff in a second, but before we do, for our people watching around the world, maybe they don't know Sysdig, or they know Sysdig, but they're not sure. Loris, why don't you maybe first we should say, what does Sysdig do?
Yeah, Sysdig is one of the leading vendors in container, Kubernetes, and cloud security. We offer a platform that covers the life cycle of modern applications, in particular, people that deploy their applications in the cloud, using modern technologies, leveraging cloud native, then they typically rely on Sysdig to secure and provide visibility for their applications.
Excellent. Now, but this is KubeCon, CNCFCon, it is a lot about open source, and it's what brings a lot of people here. And Sysdig is a big supporter of open source, always has been. But you guys have an open source project that you're very closely connected with. It is a CNCF project, right? Michaela, you're in charge of open source engineering, so I'm going to let you tell our audience a little bit.
Sure. So basically, Sysdig is the creator of Falco, which is the de facto standard for runtime security in the CNCF space. So basically, we take care about securing workloads into the cloud. We started on container and Kubernetes security, and now Falco is moving towards the rest of the cloud. So basically, we're now able not only to secure workloads on the machine, but also that are running on serverless frameworks or environments. So yeah.
Excellent. And that's Falco, F-A-L-C-O.
Correct.
Yeah. Correct? And it's a CNCF project. It's in the incubation, which for those who aren't familiar, there's sandbox, there's incubation, then there's graduation and so forth. Not many, few projects that have graduated, Kubernetes being one of them. But, how long has it been with CNCF now?
Falco was contributed to the CNCF in 2018.
So 3 years, going on 4 years?
Yeah, 3-4 years ago, more or less, yes.
And here's an interesting thing I don't know if our audience is familiar with. Companies like Sysdig contribute the project to the CNCF. The CNCF manages, including the IP and the community, et cetera. However, the connection between Sysdig and Falco remains.
Yeah.
Talk about that a little bit.
Absolutely. Sysdig was the original creator of the tool. So I, in particular, was really involved in the early days of creating Falco. So despite the fact that you contributed to the CNCF to essentially give Falco a broader audience and really make it a good part of the stack, of the standard in Kubernetes, still you continue working on that. So as Sysdig was essentially spending a lot of time and putting a lot of energy early on Falco, now we continue doing that, and we try actually to expand the intensity of our contributions in Falco as a way to, from one point of view, make the tool more and more popular, and also make sure that it's well integrated with the rest of the open source stack on one hand, but also with our commercial products on the other hand.
Right, and that's the beauty of the CNCF Linux Foundation model, right? It's a community project. Competitors of Sysdig can use the project.
Absolutely.
Customers, anybody can use the project, contribute, be a big part of the community. but yet you as the donator, if you will, the originator, still maintain sort of a special relationship, right? That allows you to leverage it as well.
It's a little bit like your child.
Right, and your children get married, but they don't stop being your children.
You always have that connection. But I also want to make clear that it's very important for Falco as a project to have a diverse set of contributors. So Sysdig is very committed to Falco, but we have many other companies, both adopters, big companies that are using Falco scale, but also other companies that are contributing to Falco and leveraging Falco in their commercial products. For example, Red Hat has just announced, like the open sourcing of their StackRox product.
Yes.
And they work with us for part of that product. So we have essentially a common way of instrumenting that we can work on together,
Yes.
as an industry. And that's good for everybody. It's good for the users and it's good for...
Well, they can't see, but that's what brings all these people here.
Absolutely.
Right, it's that ability to work on it. Let's talk about what's new with Falco a little bit. Some new news and here at the show, but what's been going on. Michela, how about you?
So I think 2022 will be focused on leveraging a very cool set of features we introduced in January this year, which is basically a plugin system which extends Falco to different event sources. So we are now able to do runtime security and process events coming not only from containers, but also from cloud platforms like Office 365 or Google Workspace or GitHub, for example. So basically, we created a layer on top of which the community can create their own plugins and then extend Falco and let Falco integrate with so many different sources, which is very, very
and
limited.
That's not a new avenue for open source tools, right? Many, go back even to like Jenkins and stuff like this. Once you start creating a plugin architecture that allows people to create their own plugins, that opens a whole new, because now everyone can start integrating what they want, not just maybe what Sysdig wants or Red Hat or a big customer, right? There's no telling what happens with that, right?
And this really came for Falco as a community as something requested by the by the users, because it's like, okay, Falco traditionally shines at looking deeply at what containers do and having the best essentially visibility into containers and the processes that are running inside these containers. And that's very important because those are your workloads, your modern workloads. But people were like, okay, but what about the cloud services? What about, I don't know, putting a password in GitHub, as part of a code commit? What about logging in without multi-factor authentication in AWS? All of this kind of stuff now can be collected by Falco, and Falco can offer this like uniform, comprehensive, and extensible kind of visibility that heavily enriches what the users can do.
Absolutely, and it also, in a way, it democratizes. I've been in security a long time myself, right? There was a time I remember in the age of SIM. SIM was everything about security, right? ArcSight, if you remember HP. And we didn't have APIs really then, right? So if you wanted to integrate your product, let's say, into ArcSight, it was, unless you had some big customer or some kind of juice there, it was a year and a half to get your integration done.
Yeah.
Then all of a sudden we came out with APIs, and you can write your own API into it, and blew it up.
If you think about that, Kubernetes is infrastructure as an API, right? And that's why it's so important for tools like Falco to integrate with it, because you are part of that API, of that mechanism, and then you can add much more value to
Absolutely.
the
And
users.
not only you, end users, whoever, programmers, anyone who wants to sees a use maybe that's not covered right now,
Absolutely.
can plug it in themselves. It's a great thing.
Yeah.
So this was released in January.
Yeah, this plugin architecture was opened at beta version last month of last year, and then we officially released the end of January this year.
Great. And they can get it at the what is the website for Falco, you know?
Falco.org.
Falco.org.
.org.
Okay, yes. Let's talk a little bit now about, okay, Falco integrating with the Sysdig commercial product. Let's talk a little bit about that.
Yes, so Falco is this very broadly used, essentially Falco is two things. One is collecting data from across your applications and your infrastructures in a way that is as efficient and as granular as possible. The second thing that Falco is it's a language, a policy language that you can use to specify essentially your rules and your detections. Users can create their own rules, but also Falco comes packaged with a very nice rich set of rules. Our commercial product, Sysdig Secure, complements Falco, so offers a bunch of functionality around Falco, like efficiency, orchestration, data collection, rule distribution, all of this kind of stuff. And then we have a team that, a research team that works on vulnerability and constantly provide the best feeds and rules for Falco. And then we have a bunch of functionality that complements Falco. Falco focuses very much on runtime security. Sysdig Secure, our commercial product, complements it with vulnerability management, with compliance, with infrastructure as code security, with remediation, so a full platform that covers the full life cycle of modern cloud-based applications.
Excellent. That was great. Any other news, maybe from the show, that you guys want to share with the audience? They're not here.
Another thing from the open source point of view that we are announcing here at the show is the expansion of our open source Sysdig troubleshooting tool. Open source Sysdig is like a TCP dump for your system calls,
okay.
Wireshark for your system calls. And traditionally it's for like deep introspection of Linux machines or containers and this kind of stuff. And we're extending Sysdig similarly to what we're doing Falco with the same plugin system.
Okay.
So that now you can use it for like troubleshoot cloud logs or your Okta deployment.
You always could use a TPC dump.
All of the kind of stuff. So imagine being able to using like TCP dump to see what's happening in your CloudTrail services log, and being able to decode it and filter it and take captures and all of this kind of stuff.
It's available on sysdig.com.
Yes.
Excellent.
So come and check it out.
Absolutely. Well, listen, I want to, first of all, thanks for being our first guest on our live. It's good to be live again. It's been,
it is.
Well, actually not true. We were in LA last year. There was that little brief episode where they were letting people out. But it's good to be here in Europe. It's good to be back live. It's good to have you on. Best of luck with Falco and Sysdig.
Thank you.
And we hope to see you soon.
Thanks for having us.
Thank you. Check it out, sysdig.com, falco.org. We're live in KubeCon. We're going to be right back with another guest in just a moment. Hey everyone, we're back here live at KubeCon, Cloud Native Con, Valencia, Spain, and what a beautiful city Valencia is. We've been having a great time here the last couple days, but we're joined now by my friend Frank Safai. Did I get it close? David.
And we were talking about Frank before. That's why I know.
You got me going.
It's okay.
All right, David. David Safai. David is the CEO of Twilio, which is probably more important for you to know actually at the end of the day. But anyway, David, I apologize. How are you liking Valencia?
Oh, it's a beautiful city. I've been
really
here once before.
Oh, you have?
I've had a wonderful time. The people are really nice. It's a great city to walk around and bike, and the food is fantastic.
Unbelievable, yeah. I went for paella last night. We had tapas. So I've never been to Valencia. I've been to Barcelona, Madrid, what a gem of a city. I mean, kudos to the CNCF for picking this town.
And to pull all these people here, I was thinking, oh my goodness.
What a great thing for
it's
the
not
economy.
Easy to get to,
no, I know.
Look at this floor.
Well, that's the bad side, is these people only see the background.
There are a lot of people out here.
There are a lot of people. And, I mean, but there's a buzz, there's an energy. And you get that with the open source community and everything. So it's great. It's great to be back.
People are excited.
It's interesting. Back in the States, we're seeing very uneven sort of response to in-person events.
Yes.
Some people are like, look, I work from home. For me to actually get dressed to go be somewhere is a bridge too far.
Yeah.
Others are, I can't wait to see live people again, right?
Yeah.
So we're going through that sort of, I guess,
we're feeling it out.
Yeah, it'll equalize, but certainly they've come out in force here for Kubernetes and Cloud Native.
Hopefully this sets a foundation for the next one, right?
I hope
keep
so.
building on itself.
I hope so, David. So look, our audience, most of the people are familiar with Twilio, but there might be people not or not sure. Why don't we start with that?
Sure.
Give them a little corporate background.
Yeah. No, thanks again for having me. So Twilio is a cloud-native data protection platform, right? And so we protect all Kubernetes-based applications. As long as you're using a CNCF distribution, certified distribution, we can detect, observe, and protect it, and allow you to really recover that application and its data. Think of it as a time machine, if you will.
Sure.
In place, into a new cluster, into a new cloud, or we can actually transform that application into other distributions of Kubernetes.
Wow.
Yeah, and so it's a great migration tool, but not just migration, but taking that next step of providing data protection and as you bring your stateful applications online.
Love it. You said something that kind of triggered something with it. You said CNCF approved distribution of Kube. Look, I'm old, right? I remember the Unix wars, and then we went through all the different Linux distros, and there's still a lot of Linux distros. Actually, I just recently spoke to the guy he was the original fellow for CentOS from Department of Energy, right? Which went to Red Hat, which was then end-of-life, but it's still part of Red Hat Enterprise. But it's not a fork, it's a daughter thing called Rocky Linux.
Yeah, Rocky.
I don't know if you heard, and it's exploding. No, it's really happening. Have we seen this in Kubernetes distros, Dave? Where we're seeing like the balkanization of Kubernetes, or?
So that's a good question. Our roots as a company, it started back in OpenStack. And so we had started to see this story. I joke around and I said it's like the movie Groundhog's Day.
Yeah, well, no,
I've seen this,
but it's
before,
true.
Right?
When you're in this business long enough, that's exactly what it is.
Absolutely. So I chuckle about that because relative to us, people start on these journeys and they say, all right, first we're going to start on a standardized distribution. And that standardized distribution, everyone packages it however they want to package it. But what Kubernetes has done really well in CNCF is to make sure that everyone stays aligned, and I think the community does really want to stay aligned. I was talking about, Groundhog's Day. I get a kick out of the fact that when people start on this journey, they think that there's nirvana in stateless, And we know, we
Just
chuckle
too
all the
shall
time.
pass, right? Yeah.
Stateful always finds a way, and so the need for data protection continues to build and grow, and we know it's going to happen, right?
Of course it is.
So, yeah, we've seen the story.
Well,
all over
you
again.
know, right, and that is true. It's, you know, meet the new boss, same as the old boss kind of thing. And I don't
As
care
long as
whether
you liked me
want.
before.
Right. I hear you. Anyway, though, here at the show, you guys are announcing sort of like a public preview, if you will,
Yeah.
of some new functionality. Why don't you, if you don't mind, share with the
yeah,
audience?
Absolutely, we're really, really excited. We are actually showing a tech preview of what we call continuous restore. We are unveiling it in Microsoft's booth, in the Azure booth tomorrow. And if anyone
How
wants
cool
to
is that?
see it in action, they can also visit us on P11. But what continuous restore is it's really, it's evolutionary and revolutionary in the sense that we all remember asynchronous replication from a traditional IoT sense. Think about this relative to the cloud native world. So we empower you as a tenant to pre-position data in multiple clouds simultaneously, regardless of whatever that infrastructure is. So now you've got one source of truth
Right.
in however many hyperscalers you want on-prem. So I can have a DR cloud, a test dev cloud, a non-prod and a prod cloud, all from
good,
one
same
source of
source
truth.
code.
And my RTO is going to be like this now.
That's what I was just going to get to.
Oh yeah, oh
I mean,
yeah.
because that's always the Achilles heel of these things. Oh yeah, of course I've got backups. It just takes me 3 or 4 months to restore. That's great. What am I going to do?
But now
till
you
then?
want to you want to recover, pick a cloud, or you want to migrate. So think of it as this mesh network. And within this mesh network now, what I can also do is from edge clouds, I can curate data and repatriate and pull it in. So
Got it.
you know, while it's great because there's a lot of great technology here on the floor, and people are talking about how do I integrate with each other more, and you know, people continue to talk about security and things. This is innovative, and
Yeah.
I want to transform this
Well,
community.
not only that, when you have this in your back pocket, you may be more willing to try these things.
Absolutely.
Because you can always kind of, and I don't want to use this, probably a trademark term, but you can always snap back.
Yeah,
Right?
absolutely.
And so go, give it a shot and see what you got, you know, and again, whether it's in a dev environment or whatever, you've got this, you know, you get out of jail free card.
Now, if you start thinking about the adoption of multi-cloud, and multi-cloud could just be multiple private clouds. I
Right.
don't care what it is, right? But this starts to become a middleware or middle layer, a data fabric.
Yep.
And I don't want to talk about multi-cloud, I want to talk about cross-cloud.
So tell me, what do you mean by cross-cloud?
So, right, cloud is a pool of resources, right? Compute, network, and storage. It's your application, your data. That's
Right.
the key. I should be able to run it anywhere, anytime, or everywhere,
Every
all
time.
the time.
I think that's a good definition then of cross-cloud.
We are really excited. So we're going to go. We'll be GA with this next quarter.
So let's just be clear, this is May, so you're talking July sometime maybe?
End of July, yeah.
Before Q3.
Yes. And we're going to, and by the next KubeCon, there'll be a very big splash around this.
Which, by the way, is Detroit, Rock City,
It's
I
going to
think,
be
in the
exciting.
fall.
It's going to be exciting.
I haven't been to Detroit in a long time either, but yeah, no, I'm going to hold you to that, though. Let's make
Please.
sure we get that.
We're really
Very cool.
excited. We're excited for the community. We want people to try continuous restore, leverage it, and they have it as their assurance tool. They have it as their test dev tool. Part of what you just have.
It's a get out of jail free card. Let me ask you a question. A lot of people watching this live right now, unfortunately,
Yeah.
are not here in Valencia.
Yeah.
They may or may not be joining in on the virtual, and there is a virtual kind of sister, conference to this. It's actually the same conference. It's a virtual experience versus in person.
Okay. Yeah.
But if they can't make that, where can they go get information outside of that?
Yeah, so there are a lot, and thank you. So there are a lot of places you can go. One, what we do have our page here, right? The web page relative to the virtual conference. You can come to Trilio.io,
That's the
You can come in and
So it'll be on Trilio.io?
ask for a demo. The team is ready, willing, and able, and you can actually talk to the other distributions that are out here. Ask them about Trilio, because that I think is
Absolutely.
one of our superpowers. Is that we try to be as flexible and as agnostic as we can, and we want to work with all the distributions.
Absolutely, man. And if you didn't catch it, it was Trilio.io, Trilio, right?
Yes, sir.
Check it out. Hey, this is exciting.
We are pumped.
Good, man.
We are pumped. Hey,
Best of luck.
so good to see you.
David, it's great to see you in person, live in
I
person.
know, stay safe.
Crazy. Stay safe is right. We're going to take a break here on the floor at KubeCon, CNCF, Cloud Native Con. We'll be back in just a moment. So, are you living in the... All right, we're live back here in Valencia, Spain for Cloud Native Con, KubeCon. We're out on the show floor itself, right here, and I think it's Expo Hall 1. There are 2 major expo halls. Lots of traffic. There are keynotes going on right now, though, and I don't know Nick. Well, let me first introduce you to Nick, then we can talk. Nick Van Wiggeren. Nick is with PlanetScale, right?
That I am.
So Nick, I mean, were you expecting this many people?
I have to say I wasn't. I thought the line to get in here looked like it was about an hour long today. It wrapped around the block. It was pretty impressive.
I came in early. Actually, I got in yesterday and set up.
Smart.
And got in early today. But yeah, I mean, and it's interesting because, back home in the States, we're seeing some really kind of uneven.
Yep.
Some shows are tracking a lot, others aren't.
Yeah.
So it's good. I mean, there's a good turnout here.
It's nice.
It is nice to see. You forget what these are about. But anyway, Nick, let's talk PlanetScale.
Yeah,
so our audience, maybe some of them know PlanetScale, some don't.
Yep. Yeah, so we're a serverless database platform. So what we are is a MySQL compatible database that starts small and kind of scales to near infinity. Marketing team wants me to say infinity, I'll say near infinity, so the engineers on the call
beyond.
Could be beyond, you never know.
Right.
But yeah, so it looks like MySQL to your application, but you don't have to worry about provisioning capacity,
that's great.
CPUs, memory. You just query the database, get your data, and we handle the rest.
So you have all the advantages of a MySQL database in a serverless environment.
Exactly, you plug your ORM if you're using Prisma or something like that in. Easy to migrate.
That's beautiful.
Yeah.
Good stuff, man. We should just get the website out of the way too.
Yeah.
Nick, planetscale.com?
Planetscale.com, yeah, come check us out. We have a really great free tier if you want to kind of get into it and just figure out what it's all about. People love it. We actually have people running their companies on the free tier.
Really?
So yeah, we're
a lot of these free
it.
tier ones, they're really great as long as they don't have more than 2 people or,
No, we don't do per seat pricing. We don't do, you want to invite the third person, well that's $10,000. We want to hook people on the good database and then get them to want to buy up for the features they can get after that.
Excellent, man, I love it. So, I mean, obviously, KubeCon is the place, Cloud Native Con is the place to be with this kind of thing, but you guys have some news actually not being announced.
Yes.
At Cloud Native
Correct.
Con. But, yeah, look, it's just between you and I and a couple of thousand people. Can you tell us anything?
I can't tell you much. I can tell you we're doing a launch week 2 next week. So we did our first launch week late last year. That's when we went to GA. And then a couple months ago in March, we launched PlanetScale Rewind, which is our schema migration undo feature.
Love that.
Kind of never seen before in the database world. We'll talk about that in a second.
Okay.
But next week then, we've got a whole other slate of features and a lot of other stuff that we're going to be announcing. So just ways to make the database better. We got product launches almost every day next week. So I'd tune in on PlanetScale Data on Twitter. It's going to be a fun week.
Very good, man.
Yeah.
That sounds exciting. Good luck with it. So let's talk about replicating database schema.
Yeah.
Instantly.
Yeah.
So Rewind, is that what you called it?
Rewind, that's what it is, yeah.
Okay.
So I come from a kind of infrastructure background. I've worked at companies like GitHub, DigitalOcean, kind of real, giving developers what they want, really deep infrastructure. And figuring out how databases don't exactly always work well on that, right? The DevOps world, the application world has really gone far, and the database world hasn't necessarily kept up. Still using a lot of the same technologies, still fielding a lot of the same problems, right? Yep. You've got this beautiful, K8 stack, and then people are like, well, we don't run the database on it, well, we can't do that. So what we want to do is we want to bring all the kind of fancy, fun stuff that application developers have to the database. So one of the first things we did was what we call Rewind, which is a schema migration undo feature. Just like you can roll a bad deploy back, you go out, you say there's a bug, click the button, maybe your canary catches it automatically. We want to do the same thing for databases. Instead of having to restore from a backup if you do a bad schema migration or take a bunch of downtime.
And we know how long that could take.
I mean, we've all been a part of this, right? You drop a column you shouldn't have, and then you're 3 hours into pulling a backup down from S3, and
it's a pain in the ass.
You got 10 people in the incident room, all
yelling
staring at the same progress bar.
I hear you.
Yeah. So instead what we did is every schema migration that goes through PlanetScale, and we have this great kind of collaborative online schema migration workflow. If something goes wrong, we give you a rewind button or an undo button. And for 30 minutes after the deploy, You click that button, and we'll revert your database and your data back to what the old schema looked like. So you won't have to lose any rights that you did during that 30-minute period. We'll just make the database look like it did before with all your data added in afterward, and pretty much instantly.
Very cool, man.
So, yeah.
Excellent. You know, so look, I've been in technology a long time. The database, for as important as it is always a little bit of like the forgotten kid.
100%.
And it's always like the last one to get the cool features.
Yeah.
You know, and so, I mean, it's great that you guys are doing this, don't get me wrong.
Yeah.
But you say to yourself, why was the database the last one to get this?
You know, I think, you know, when you look at it, it's the part of the stack that's maybe the most important from a pure operational perspective. You can play around with a lot of other stuff, but the trust that you have to have in the database, it's got to be rock solid, it's got to be dependable, and that then inherently means that there's fewer changes and the velocity is slower. And that's probably a good thing for some reasons, right? You can experiment with a new front-end framework and ditch it. You can experiment with a new application deployment platform and go, we'll deploy the code somewhere else. But database migrations take weeks, months, years to do. And so I think people have been pretty hesitant in the past to really march forward and try to innovate. So at PlanetScale, what we want to do is, right, we want to be able to have that trust, the performance, the dependability, the rock solid database kind of foundation, and then build features on top that actually help application teams do the stuff that they want to do. And, well, you know, I like to say we're outcome oriented, right? Yep. We want to help companies build the stuff they want to build. We you know, yeah, there's benchmarks, there's this, there's that, but at the end of the day, our success is when our customers go, well, thanks to PlanetScale, we can get done what we need to get done better and faster.
That's a great thing, man. So we've got, next week is our big week.
Next
we've
week's
got
the big
Rewind.
week. Yep.
Anything else happening CNCF-wise here?
Yeah, so we've got a couple talks. We got some engineers around. I think there's a test booth over on the other side of the pavilion as well.
Yes.
So we've got some folks from PlanetScale who are Vitesse core contributors and stuff like that who are there to answer questions about the open source project we're built on top of. And I mean, we just love the CNCF. We love everything they do. We're built on all these technologies, obviously Vitesse, but also, you know, Kubernetes, Thanos,
well,
I mean, you name it, you know?
Dog food, right?
100%.
I agree with you, man.
100%. It's our stack, it's our livelihood, and we're just really happy to be able to build on top of it all and deliver a product thanks to the hard work of everyone here, honestly.
Excellent. Hey, Nick, I want to thank you for stopping by.
My pleasure.
Good luck with the big releases next week.
Make sure you check it out. Don't miss it.
We will. We'll try to, well, I know we've been talking, we'll try to get some coverage on it.
Definitely.
On Container Journal and DevOps as well.
Awesome,
so.
We'd appreciate it. Thank you so much.
All right.
Have a great
Nick
rest of your
Van
day.
Wiggeren at PlanetScale. We're live in Valencia. We're going to take a break for some sangria. We'll be right back. All right, man.
I appreciate it. Thank you.
I appreciate your Hey everyone, back here live at in Valencia at KubeCon Cloud Native Con, continuing our day one coverage here at KubeCon. My guest right now is Anish Dar. Anish is the CEO, co-founder of Cortex.
Yep.
And like me, he's come a long way here to Valencia, but having a great time in this beautiful city. Anish, welcome, how are you?
I'm doing great, thanks for having me.
Thanks for having us, thanks for coming down here with us. So Anish, I think we need to, first of all, look, everyone watching this live right now is not here.
Yeah.
Almost by definition, right?
Absolutely.
So, we should talk a little bit about what's going on here before we even jump into Cortex.
Makes sense.
You know, I've attended a bunch of KubeCons over the years.
Yeah.
This one kind of feels like the old ones, right?
Yeah.
There's a buzz, there's a critical mass of people.
Yeah, it's nice to see you in person.
Yeah, well, it really is. I don't know if you got to the one we did in LA.
No, I didn't know.
There was like that brief window where things opened up a bit.
Yeah.
And
Yeah.
the LA one was nice, but it was sparse in terms of people.
Definitely. You can feel the excitement here.
Yeah, no doubt. So for those who are at home, I wish you were here. There is the virtual event though that's paralleling this, and you can do that. But Anish, let's talk a little Cortex. For people not familiar with the company, why don't you give them a...
Absolutely, so Cortex basically helps engineering teams understand and improve their microservices. So we catalog all your services and integrate with all the tooling in your company. So we'll tell you who's on call to the service, to where the documentation for it live, and then we help you grade the quality of these services across things like production readiness and security standards. And so it's a great way to get visibility into what's being built at the company and whether it's meeting the standards of your engineering team.
Now, does it is it like an automated process of gathering all your microservices?
Yeah, exactly. So we can do service discovery. So we'll integrate with things like Kubernetes or your Git repos or APM tools, and then automatically map services to all the data around them. And so we can just ingest into your platform and then pull everything out and kind of do a lot of automated guessing on where everything lives.
Excellent. Excellent. Now, you guys you've had a rapid rise in terms of growth and stuff like that.
Yeah.
But you know what, Anish, quite frankly, a lot of companies in tech did over the last few years.
Yeah.
The whole digital transformation and everything. But what do you think is what's really driving the business of Cortex?
Absolutely. I think what we're seeing is that software has become incredibly complex, and it's become a core part of every company, right? Every company becomes a software company at the end of the day. And it's not just microservices. What goes into your software is databases, pipelines, libraries, so many different components, and each of these has their own owner and comes with their own set of tribal knowledge. And as your company scales and gets bigger, it just starts living in people's heads on like what's a good quality service, who owns this, who owns that. And then when there's an incident, it becomes incredibly difficult to triage and figure out who's actually responsible for the service, where are the downstream dependencies. I think all of these things really impact developer productivity and efficiency. And so that's why, if you look at our customer base, we have companies like Roblox who, obviously technology first, reliability is very core focus, but we also have customers like Restoration Hardware, right, who also have services and, they build software, and it's very important for them that, their services are reliable and secure, and engineers have understanding of what's going on. And so that's why I think really, when we raise our Series A, I think we really pitched it as, if you're a software company and you have over 80 engineers, you're facing the problems that Cortex tries to solve.
Absolutely. One of the things around microservices, Anish, we've seen, and we speak to a lot of companies, obviously, is there's this misconception. You could have an application, let's say, that's running a half a dozen microservices.
Yeah.
You could have an infrastructure that's running dozens of microservices.
Yeah.
And then, there's a segment of our audience that says, hey, we're running hundreds, if not more, microservices.
Absolutely. Yeah.
In your experience, what's the sweet spot?
Yeah, I think that traditionally we've seen you between like that, once you hit 50 services, it's when you start thinking about how do I organize this in some way. And we see companies introduce service meshes around then, They'll use Confluence or Google Docs to organize, where each service lives. And then I think around 100 services, it's like, okay, I need something. So, like
the spreadsheet isn't doing it
Yeah, the spreadsheet
anymore.
isn't doing it for us. And so most of our customers are
So that's
between
your sweet spot.
Yeah, I'd say 100 to like all the way to 500 services, but then you also have, thousands of services like a Roblox situation where it's just, they were, adopted microservices very early, and now it's just kind of this, Wild West.
So that brings up an interesting question though then. It's sort of like if you look at, the universe since the Big Bang.
Yeah.
And you see it, expanding.
Yeah.
Is the amount of microservices an organization running directly just related to how long they're running microservices?
Yeah.
Or is there like certain like implosion or explosion points?
Yeah. It's interesting. I think it's almost tied to the growth of the engineering team, because I think, companies introduce microservices so that they can start shipping code faster, so there's continuous deployment. There's a lot of benefits to introducing a service-oriented architecture, but then what ends up happening is microservices create autonomous teams that, are very siloed from the rest of the company. And so, for example, I used to work at Uber, and I understood the services on my team, but there were thousands that were being built all across the company, and I just, they're named after like TV shows, and so it becomes difficult for engineers to really understand what's going on. And so I think they are a natural evolution of growing as a company, and they start scaling because engineers just start spinning up services to do different things, and I think it kind of gets out of control.
Yeah. Don't say that, because, so is this evolution to chaos sort of the natural evolution then, you think, that you absolutely need a Cortex kind of thing to try to wrap your head around it?
I believe so, and I think, a lot of our customers had built internal versions of Cortex before migrating, and a lot of times it's for compliance reasons even. It's like, we need to know who owns a service.
Right.
The recent Log4j vulnerability, it caused so many companies to look at their service architecture, and it was really difficult. How do you tell who owns a service? That exercise can be really difficult for most companies. It doesn't matter if you have microservices or not, even in a monolith, there's, different services and people own different parts of that monolith. Same set of issues, it's just a different way to kind of name the problem.
Got it. All right, excellent. New news coming out maybe in a couple weeks.
Yeah, so we're working on this product called Resource Catalog. So right now, you can represent anything you want in Cortex. It's just YAML files to represent your services. But we're actually going to be building native integrations with things like AWS and other resources to actually pull them in. So you'll be able to say, hey, this service depends on these S3 buckets, these databases, and then visualize that in like a dependency graph. And so it's going to be really interesting being able to represent your infrastructure inside of Cortex.
Very cool.
Yeah.
I don't know if we mentioned the website, did we?
Yeah, so you can just find us at cortex.io.
.io.
Yeah.
Hey man, Anish, thanks for stopping by here.
Absolutely.
Enjoy Valencia, enjoy the rest of CNCF.
Thank you so much.
Check out Cortex at cortex.io. We're going to take a break here on the floor of KubeCon. We'll be right back. I mean, well, I fly business, so it's not like I'm sitting in the lines or anything.
Yep.
But still, I mean, it's been a long. Hey everyone, we're back here on the floor at KubeCon, Cloud Native Con, Valencia, Spain, 2022. What a great event. I'm joined now by Kapil Sangavelu. Am I good?
You got it.
Kapil is with Stacklet, and you know what? I'm going to let you introduce yourself and the company, Kapil.
Sure.
Why don't we do that?
Stacklet is a cloud governance as code platform delivered via SaaS that helps companies be well managed in the cloud. And that's inclusive of doing security, doing compliance, doing cost optimizations, all through sort of a GitOps delivery, using the open source project Cloud Custodian to power YAML policies that help companies achieve real-time compliance.
Excellent, good stuff. And you are, what's your position there?
I am the CTO and co-founder of the company, and then previously, when I was at Capital One, I helped create the Cloud Custodian project and open source it, and now bring it into the CNCF, where it is in the sandbox.
And Capital One is, look, my friend Dr. Paul, you know Paul? So, ProCop Paul is, he was at Capital One a long time. But he was one of the ones who really kind of began their, let's call it their embrace of open source. Right, at a time when a lot of banks would never...
Topo, yes.
Topo Paul, right.
Yeah.
At a time when banks would never publicly say they even used open source, he was kind of preaching in the wilderness, right, about not only are we going to use open source, we're going to develop open source, and we're going to give the open source to the open source community. And what a great thing, and in many ways, this is like a byproduct of it. Or this is
one realization of that.
Right, exactly. Why don't, if you don't mind, if we got some time,
sure.
Talk about that journey.
So, I joined Capital One in 2015 as part of the Tech Fellows program. I was coming from Canonical, makers of Ubuntu Linux,
Sure.
and they were just beginning that cloud journey. They had decided to go all in it, but they were also really passionate about doing open source well, and they wanted to set examples up for the org. So Topo,
Right.
Dr. Taprabata, was one of the leading lights for that, and Cloud Custodian being open source in April 2016 was the second project that Capital One had done in that open source fashion. I've been in open source for 20 years, and I've watched it go from that fringe group of hippies on the side to the de facto way all software is built. And so seeing that, when you're doing that, being able to influence that open source, being able to contribute back to it, is a key part of both making your own projects better, as well as contributing back to the larger community. And I think a lot of banking and some sectors looked at it as secret sauce, but it's not secret sauce. Like, it is undifferentiated lifting from business value, and by contributing back to it, you help influence the direction so that it's better for you.
Love it. All right. So now we come out of Capital One. There's this open source project they've put out there, and you start or co-found.
Well, I actually took a year to work at.
So there's more to the story.
There is a little bit more. So I've been doing open source the last 20 years, and I wanted to ensure the next 20 years of open source. And I saw a lot of companies that were not only open source switching licenses, going to business software licenses, things that no longer met the OSI definition of open source because they prevented against particular fields of endeavor. And I saw the biggest challenge with that was getting the cloud providers themselves to contribute back to projects that they were running as services. So I joined Amazon under Adrian Crockraft at the open source team there, and tried to work with service teams to get them to contribute back and to understand the value for their end customers to contribute back to the upstreams. Did a year of that, and then started Stacklet. It was March 11th. I remember that day well because WHO declared a global pandemic. So born and raised during the pandemic, so to speak.
Wow. Actually, I remember that day as well. So we had done the RSA conference show in California, San Francisco. And after that, we went to Napa for the weekend. Because my anniversary is right around then. I got on a plane coming home, and we heard that people at RSA had gotten sick. Because it was kind of not really talking about a lot then. Got home, went to work that Monday. I think we closed the office that Tuesday or Wednesday maybe. And yeah, crazy. So.
Yeah, my co-founder was visiting me in the Northern Virginia area, and we're like, he lives in Kentucky, and we're like, you should go home because we don't know like what they
if you're going to be able to get home,
like what's going to happen.
Crazy time.
It was crazy time.
At some point, we'll write the history of this time, and having started a company, right in the middle of this pandemic will be a great story and a great learning lesson. But I also always believe that when things are like that, when the cycles are flowing like that, it's a great time to start a company.
Absolutely. I mean, I think a lot of companies born in the pandemic, it was really just a question of embracing remote. Like we have engineers that live all across the globe, from New Zealand to Europe to North America, South America, and so I think I've seen that trend play out numerous times. I ask any startup around on the floor, where are you guys based? Everywhere is the first answer. So, and I think it also brings a lot of interesting challenges to how you engage with customers, how do you get your message out, and being part and born of the open source community, like that is already part and parcel of how you engage.
Agreed. All right, let's talk about the company, the Stacklet, and the product itself now. This was a great discussion around the other stuff. So, it's not a CN, well, I don't want to put words in anyone's mouth or start up a thing here. Relationship here to the CNCF and the whole community.
So Cloud Custodian has approximately 350 contributors. Stacklet employs several of those contributors, and Cloud Custodian is a CNCF sandbox project looking to go to incubating, hopefully right after this conference.
Let's hope so.
Knock on wood.
Yeah.
It's been a long journey. And then Stacklet takes Cloud Custodian and tries to give people an out-of-the-box business value with it. So delivering a platform that can operate at scale across all of your AWS, GCP, Azure footprint, and then delivering policies as code through GitOps delivery, and then visualizations and reporting. The open source is just a CLI, and so being able to operate that at scale, for many organizations requires staffing up and building out teams for it, and we try to give people that out-of-the-box value so that they can just take advantage of it.
And you're providing a real UX, not just the CLI.
Correct, correct.
So what do you think is more important, that UX or the team's scalability situation?
I think it's
both.
I think it's a couple of different things. So I think, to deliver value in the organization, you want to have something that helps visualize the results, but we also deliver policy packs which can cover off on hundreds of different value chains, from security or cost optimization. And then you also want to be able to do the operations at scale, like being able to take something from a CLI to operating at production across thousands of accounts requires some engineering work. And so being able to provide that value to organizations out of the box really just helps accelerate them. And then of course we do all of this policy management through GitOps. So we want to be able to have our infrastructure or policy as code deployed the same way that you do infrastructure as code. So being able to run that same process, being able to do stage rollouts to different environments, all through the same techniques that you run any of your application or infrastructure development.
Love it. Kapil, I want to stop you for saying goodbye today, man.
Thank you,
Have
Alan.
a great time here at Cloud Native Con, KubeCon. You know, Stacklet, what's the website?
Stacklet.io.
Stacklet.io. Check it out. We're going to take a break here in Valencia. We'll be right back with another guest in just a moment. I'm sorry.
I'm joined by Mike Ferranti, is that correct?
Ferranti, that's right.
Boy, I got that right. Good to be meeting with you, Mike.
Yeah,
Mike
likewise.
is CMO with Teleport. Welcome to the beginning of KubeCon, Cloud Native Con. Wow, I'm impressed. It's a good turnout here. I haven't been to a show like this in a while.
It feels normal.
It does. It does. Other than, I have to take your map and put it on all the time.
Temperature check and all those things. I think those are going to be with us for a while, but it's great.
Too.
After a couple years off at trade shows, actually talking to people and just getting back into it.
It's funny to bump into so many people in one place again, what was normal used to be anyway.
Now there's the game of I think I recognize them, but I'm not quite sure.
I never paid that much attention to your eyes before. Now I know who you are, right? So tell us about the show for you, for Teleport. Now obviously you're in the access management into the cloud. Kind of what's special about KubeCon and why you're here and what you're talking to customers about.
Yeah, so I guess, to maybe set the context. So Teleport is, we describe Teleport as the easiest and most secure way to access infrastructure, and there are kind of two important parts of that sentence. There's the secure and there's the easy. Mm-hmm. A typical DevOps engineer walking around this show on a daily basis has to access dozens of different systems. And each of those systems has its own way of managing secure access. Mm-hmm. If it's a Linux server, we're talking about SSH. If it's Kubernetes, then Kubernetes has its own way of doing role-based access control. Each database protocol has its own way of doing auth in and auth z. Yep. Internal applications, Windows servers. And so, kind of as an individual DevOps engineer or an SRE or a systems architect, I'm kind of constantly swapping credentials, logging into vaults, retrieving credentials to access this server. I might be a part of the team that has to do all of the key rotation to make that work for all the different engineers on the team. And then, even if you've done all that, the audit layer for who is accessing what and when and what they're doing is incomplete. And so what Teleport does is we provide a very easy to use experience to implement role-based access control for all of your infrastructure resources with complete audit built in. And so it's easy for systems architects to implement, and then for individual DevOps engineers and other engineers to use and consume on a daily basis.
Yeah, I think all of us, developers too, kind of look for the easy button, especially when it comes to security, but we want it to be secure. So, accessing all those resources and managing the roles and permissions, now you've got machine identity in the mix too, because we're, microservices and Kubernetes and different architectures, we're all talking services to each other, whether it's ours or third party.
Exactly.
Talk about what Teleport does there.
Yeah, so we looked at the numbers and they're something like 22 million software engineers worldwide. But there are literally billions of, we could call machines out there, pieces of software that themselves are programmatically accessing other pieces of software. And so when you think about solving the access problem and making secure access a reality, you have to focus on what machines are doing as well as what people are doing. And the same solution that works for a human, right, isn't going to work for a machine because, right, I can touch ID into my laptop with Teleport and get immediate access to all of my infrastructure resources, but my Jenkins bot or my Ansible bot can't do the same thing. So one of the things that we recently announced is a product called Machine ID. It enables organizations to consolidate their access policies that they're already using Teleport to manage with their policies specifically for machines. And it makes it really easy to take advantage of identity-based access, but extended to a new class of users.
Mm-hmm. Yeah, it seems that one of the things about machines is, as much as we move around and change roles, change jobs, whatever it might be, machines are doing that constantly, driven, automation driven through software.
Highly
dynamic. That's got to add a lot of complexity to, trying to do it by person, by hand, more or less, managing it through a Teleport or other kind of solution. That's got to be a big part of the problem you're solving.
Yeah, one of the things that we say is that kind of Teleport solves access at scale. Pretty much anything in life, when you just try to do it, one or two times, or for one or two things, most things in life are relatively simple. It's like having a dinner party for 4 friends versus doing catering for a 10,000 person event. Very different level of scale. And it's the same thing for access. It's easy-ish for a team of small engineers to just manage SSH keys, have a couple of different roles that they apply to kind of shared admin credentials. It's a small group, you trust each other, but once you scale to dozens or hundreds or thousands of engineers, or there's those same numbers for machines, solving access in a consistent way becomes very challenging. And with machine identity in particular, because of the numbers that we're talking about, spinning up and spinning down huge clusters, you really need to be able to leverage automation to create credentials, give those credentials to the system that ultimately is going to need to have its access controlled, rotate those credentials. And so one of the innovations that we brought with Machine ID is, just like Let's Encrypt made it very easy to get SSL certificates for websites, and now you have hundreds of millions of websites that are more secure because of the Let's Encrypt project. We're doing the same thing for machine identities, and basically running a certificate authority for you so that you can kind of create, deploy, and rotate machine identities, or certificates for machine identities.
You're not relying on a third party to go get your machine certs. Plus, you'd also be able to rotate certificates much more shorter time to live.
Exactly, so by default, all of our certificates are always short-lived. One of the things that we found in doing research for this product is that sometimes people had moved to certificates because they understand kind of the more metadata about a user can be embedded in a certificate than you can in say a key, right? A key, if you have it, you're allowed access. With a certificate, I can actually understand who you are. But because certificate rotation is such a challenge, people were creating these long-lived certificates, which defeats the purpose, because then it becomes just another secret that if it's stolen, hacked, can enable someone to get into your infrastructure. Solving that problem requires that you kind of master rotation. And once you've done that, then you can have short TTLs, kind of, and all the security benefits that go along with it. But it comes at a kind of a complexity cost, and that's one of the specific things that Teleport does, is we reduce that complexity cost down to 0 for you, so you can take advantage of certificates the way that they were intended to be used.
You don't have to implement those 180-day password expiration policies like we do with people.
Exactly.
I'm really curious, so a solution like Teleport, is it usually the developers that are bringing it in to kind of help solve the complexity and the volume problem, if you will? Is it often imposed for compliance reasons or by security teams, or a little bit of a mix of both?
Yeah, it's a little bit of a mix of both. I would say that we, the people that are most passionate about Teleport today are the security-minded engineers. They're the practitioners. They're the ones that are building these systems, but they also understand that those systems need to be secure. So it's a very common use case would be, you walk around here, you're going to see dozens of Teleport customers, and they are the types of companies that are building a next generation database and they're selling that solution to perhaps a VP of engineering. And that database provider has their own customers, and those customers are going to say, okay, like, I love your database, and I want to take advantage of running it in your cloud as a managed service, because then I don't have to do it myself. But how secure is it? Are your employees able to access my data? How do you know if they have? What kind of audit do you have in place? And what Teleport does is we enable our customers to solve those security and compliance concerns that their end customers have, kind of by passing through to Teleport. So it's kind of a win-win situation.
Plus, it's all that data is collected. Evidence is there.
Exactly.
Great. Well, where can folks find out more? And do you have like free demos, open source? What kinds of ways can they engage with you?
Yeah, so Teleport's completely open source, so always love for people to just go to goteleport.com. You click on the button at the top, it's going to bring you to a page where you can access our open source download. If you want to try Teleport in the cloud as a managed service from Teleport. There's a way to do a free trial for that as well. Plenty of ways to contact us if you just want to get a demo, learn a little bit more about how it works in your environment. All of those options are available.
Great. Sounds like the security champions on those DevOps teams would be great candidates to go check it out. Well, anybody would, but they're the folks that, the security-minded engineers you're talking about. Good, good. Well, I hope you had a good show, and excited to see more of those Teleport customers around today, and I hope you come back. I know you've been on before on Techstrong TV.
Always happy.
Always good to have you folks here. Mike?
Great.
Good to see you.
Yeah, likewise.
Hi, my name is Max Gagliardi. I'm the co-founder of the Ancova group of companies, as well as the host of the Talk Energy podcast, which is a podcast that I started about a year ago, which covers kind of a wide variety of energy topics. I have leaders on from kind of the energy space and try to touch on a little bit of everything with that. So this presentation that I put together today is called Bitcoin, Energy, and Decentralization. The Ancova group of companies historically has been a energy-focused group of companies. We do natural gas marketing and sales. We do midstream and energy infrastructure. And so you may be wondering why an oil and gas guy is up here talking about Bitcoin at a tech conference. And I'm often thinking that question to myself some days lately. But the last year, our company has been very involved in the Bitcoin space. And hopefully through this talk, I can tell you about kind of how I got to this point, what we're doing in the space, and how it interplays with energy. And I'll kind of go through in the order of the presentation is really start off at the beginning, kind of talking to the technical aspects of Bitcoin. And I'm not a technical guy. I've worked with engineers and scientists my whole career, so I'll do my best to try to describe it as simply and concise as I can. Some people have varying levels of understanding of Bitcoin. So for some of you, this may just be stuff that you already know. For other people, it may be something that you've never heard before. So I'll try to talk about the technical aspects and then break it down in layman's terms. And then the middle part of the presentation is kind of about energy and why I think it's important. And then the last part of the presentation is kind of around some of the FUD, the fear, uncertainty, and doubt around Bitcoin, and then why I think the case for Bitcoin. And then I'll just touch briefly on like what our company does, and Ancova Digital, which is our Bitcoin platform. So and then do questions. I'd love to do some questions, so I'll try to finish early. So Bitcoin 101, Bitcoin, and this is taken directly from the white paper, so this slide, and the white paper was written by Satoshi Nakamoto, who is the inventor or inventors of Bitcoin, who are an anonymous person or persons, and this is part of the very first paragraph. So I'll read through this, and then I'll break it down in kind of layman's terms, but Bitcoin is a purely peer-to-peer electronic cash system that allows online payments to be sent directly from one party to another without going through a financial institution or trusted third party. The Bitcoin network timestamps these transactions by hashing them into an ongoing blockchain of hash-based proof of work, forming a record that cannot be changed without redoing the proof of work. And the longest chain, or the longest ledger, which is basically what the blockchain is, serves as the proof of the sequence of events that have been witnessed. And the longest chain comes from the blocks that show that they have the proof of work, which is the CPU power. The messages are then transmitted across the blockchain, and every node on the chain validates that each block has that proof, and that effectively forms what the Bitcoin network is. And so another key thing to remember is that whenever a block is formed and the proof of work is done, you get a reward, which is Bitcoin. Only 21 million Bitcoins will ever be created on the network. So first time I heard that, I kind of glazed over reading the white paper. I was like, okay, cool. This is like internet money that you can send back and forth to each other. This is kind of neat. I didn't really think through the ramifications and the implications of what something that was truly peer-to-peer that didn't have a trusted third party, because there's really nothing like that we have. And so for me, it took a while to really think through that. Just because, again, there's nothing that we experience day to day. Even if you use Venmo, it feels like you're sending money from some person to another person, but there is just this huge stack in between of financial institutions and all these things going on. Or for example, when you use your Apple Pay at the store, it doesn't just settle right then. In fact, sometimes settlement of that payment can happen weeks later. So there's this big kind of cumbersome system in the financial network. And with Bitcoin, it is literally peer-to-peer with zero trust or zero institutions in the middle. And so I'll talk about later why that's a big deal, but it took me a while for that kind of to click. So the way that the network works, and I'll try to just explain this simply, effectively, there are transactions. So I trade a Bitcoin to you, you trade a Bitcoin to me. That transaction gets broadcasted across nodes, which are effectively small computers that people can run, individuals. Like I run a node at my house. I don't get any money or get anything from that other than there's some privacy things that's nice about running a node. But each node effectively contains the entire blockchain. So every time a new block is added, it gets broadcasted to the network. It stores it on that node. And nodes can do different things, and I could talk a lot about it. But effectively, each one of these nodes is like a small computer with a hard drive. The miners, which are these powerful computers called ASICs, are processing these transactions and batching them into these blocks. And a new block is created roughly every 10 minutes. And so not only are the miners processing the transactions, they are solving a cryptographic puzzle effectively. So think of it like I don't know if anybody's watched Harry Potter. I've seen it some. I think the game is called Quidditch, where they fly around, they try to catch the golden snitch. And if they catch this elusive thing that flies around, then the game is over and you win. And that's kind of how it is with these blocks. Like if they can solve the puzzle and show that they did the work, they then can stamp that block with the proof. So when they broadcast it to the network, everybody on the network can trust that this is a valid block. So there really doesn't have to be anybody saying this is true, this is false. Because of the proof that it is a valid block. And so once it shows that it's valid, once they solve the puzzle, they broadcast it to the network. It's then validated, and then the process repeats, and you add blocks to the blockchain. And it's effectively just a giant ledger, which is essentially every transaction back to the very first block. And so it's just a record of all of it. Like I said, every 10 minutes is the target time to create a block. If it's happening faster than 10 minutes, so if it's happening in 9 minutes and 50 seconds, then that means more computing power has been added to the network. If it's going slower, so it's 10 minutes and 30 seconds, that means computing power has been taken away from the network. So roughly every 2 weeks, the network will recalibrate and try to target that 10-minute interval. And so what that means is it'll either get harder or easier to mine for the blocks. And so each time, again, when the miner finds the puzzle, they get rewarded with Bitcoin. And so there's this natural incentive system to expend the computing power, expend the energy, and then get the reward of Bitcoin coming back to you. And so we'll kind of move on. So there was a problem in computing when it came to systems, and this is a problem that people thought couldn't be solved for, I think, decades, basically going back to when the first networks were being created. And it was called the Byzantine's general problem. And essentially what it was that how can you have a network where you don't need a trusted intermediary or a centralized figure that's validating what is true or what is false on this network? And the analogy was you've got 4 generals or some group of generals. They're all different, nations, and they've banded together to attack a single foe. And so the only way that they communicate is by sending messages to each other. And so how do you know that that message is valid? If 3 of the generals are saying attack and 1 of the generals is saying retreat, and that general is a traitor or a bad actor, how can we validate whether it's true or whether it's false? And so there has to be some kind of proof that that is a true message. And this is the problem that you faced with networks. So if it's like your Visa, it's easy to figure out whether these transactions are true or false because your Visa and you house everything in a centralized database and you control it, and your systems engineers and software engineers have put it all together. So you kind of know, hey, is this in our system or isn't it? If it's a distributed system like Bitcoin, you've got independent actors all around the world that are processing these transactions, that are sending Bitcoin back and forth, that are mining for Bitcoin. How do you find a way to make it to where you don't have to have somebody who's the gatekeeper? And proof of work, this idea of proving that the message was true, was really the invention. Proof of work coupled with the difficulty adjustment was really what solved this Byzantine's general problem, which many people thought couldn't be solved. And so this is kind of important to think about when you think about the energy consumption and why it's doing what it's doing. And so Bitcoin is just this kind of incredible network that has never been hacked. It's never really been materially compromised. It's been going for 13 years strong. I think it was 13 years. This October 31st was the 13th year since Bitcoin launched. And proof of work has really been at the heart of why this network is so resilient, why it is so anti-fragile. And if you think about it again, I'll break it down. So the process goes where you have to use this electricity and apply this computing power to guess the answer to the puzzle, right? The more energy that the Bitcoin network uses, the stronger the network is, the harder it would be to compromise this network. The Bitcoin network benefits also because it has got the network effect. It's been doing it for 13 years. So people, and we'll talk about all the questions for Bitcoin later, people say, well, why can't there just be another Bitcoin? Well, there is millions of these computers around the world hashing, and hashing is basically solving these calculations. And it's some crazy number. It's like every second there's more hashes than there are like stars in the visible sky. I mean, it's like there's just an insane amount of computing power going into this network. And so the more energy that's expended, the more secure the network is, the more anti-fragile it is, and the more resilient. And so it would basically take just a monumental effort to compromise the Bitcoin network. Again, it's never happened. A lot of people have tried. In fact, there's tons of people every day that would love to try to do something to hurt Bitcoin. But compromising the blockchain would not only be very costly, it would just be unprofitable. So the amount of computing power that you'd have to put towards compromising the network would be far more expensive than just mining the blocks and getting the Bitcoin reward. So you're incentivized, not only would it be very hard and almost just logistically, I don't want to say it's impossible because nothing's impossible, but not only would it be a huge logistical undertaking, it would be very unprofitable to do so. And so it's not just the energy consumption. When you first think about proof of work and finding out how to have that proof to show that your block is valid, it is the logistics, it's the manpower, it's the technical expertise. As a company that is mining Bitcoin, it is literally hundreds, if not thousands of hours of thought and prep and effort, as well as massive physical infrastructure that goes into the proof of work. So it's not just as simple as I could just expend more energy than them. There's a ton of stuff that goes into proof of work. And so this cartoon, I kind of like it. Basically, just read through it real quick. It says that if everybody's working on block 91 in the network, and one miner wants to go back and change block 74, he would have to make changes and redo all the blocks between 74 and 90, as well as change the block 91. So that's 18 blocks worth of computing power. And the kicker is he would have to do all of that before the people at block 91 solve for that block. So if you can imagine, it's just the higher or the more stacked up the blockchain is, the more difficult it would be for someone to go back in and compromise historical transactions. And so this is just a cool way to visualize it. And so that's basically in a nutshell. And for me, like I've spent my whole career kind of at this intersection between energy and value and monetizing energy. And so like I had to understand this part of it before I really got Bitcoin, because people were coming to us and saying, you can take energy, whether that's stranded energy like natural gas that didn't have a sales market that was being flared, or whether it's grid energy that's being wasted, and you can otherwise monetize that energy into a much higher value. And for somebody that spent a career kind of, duking it out to make 10-cent margin on natural gas. So for example, nat gas trades at like $4 today. So, if you could find 10 extra cents somewhere in that value chain, that was a huge deal. You could make people millions of dollars for just that little bit of value. And so we built a whole business around this. And when I found out that you could sell natural gas and effectively equate it to $35 per MCF, which is roughly where it's at today, I think it may be a little lower, around $30 per MCF. It was like a earth-shattering, like I couldn't sleep for 2 or 3 days type of moment, because I just thought this just can't be real. This has to be something that's fake, or my entire career and everything I've like worked on doing is going to change. And so I had to dig into this and understand why it was expending the energy for me to really get excited or get on board with actually pursuing or going down the path of doing things in the Bitcoin space. And so that's why I started with proof of work and trying to just tell you about the basics of the network. It's kind of the secret sauce, and it's what makes it be able to be decentralized. And so kind of moving on, Bitcoin's energy usage is also something that it's often attacked for, right? And so hopefully you can understand it is because the energy usage is what makes Bitcoin Bitcoin. It's why we can have this trustless system. It's the proof of work. It's how we can prove that these transactions are real. And so you see all these people attacking Bitcoin, saying it's going to boil the oceans and that it's accelerating climate change and all these things. And I actually think Bitcoin's energy use is a good thing. And again, this has taken me some time to wrap my head around, but it's the first time in really human history that we have a large scale use of energy that is effectively agnostic to location. So Bitcoin, when you mine it, it is a very small broadband in terms of what it takes to send the signal to the network. So you can use a cell phone modem, you can use a satellite modem, and you can effectively put the Bitcoin mining anywhere. And so again, when you first hear this, you're like, okay, that's fine. You can stick a mine wherever, back behind whatever it is and plug it in. But when you think about it, and you think about energy, like I have my whole career, all of energy is effectively this game between getting supply to demand. So this microphone is plugged in here. It runs through a cord that's plugged into the wall. You can trace this with a physical object. You can trace this all the way back to a literal source of energy. There is probably a natural gas well or a coal power plant or a windmill or solar panel somewhere in the earth that is far away from here, probably relatively far away, that you have to physically trace that energy to get it to this microphone or to this computer. And so this idea of being able to take large scale demand for energy and move it anywhere to where there's supply is, again, there's just never been anything like that. And not only is it a large scale demand for energy, it is also today, currently at the Bitcoin price and the hash price for the network, it is the highest value use case for energy. So like I mentioned, the natural gas, what I talked about with natural gas, like even retail power is probably at my house, it's around 9 to 11 cents per kilowatt hour. Right now, mining Bitcoin, depending on how powerful your ASIC computer is, you can get potentially in excess of 30 to 40 cents for that energy. So it is, not only can you move it anywhere, it's the highest value use case. And so then you look at all the applications for this technology and you start to extrapolate it. There's just so many things it can do. So for in our industry, you have what we call flared gas or wasted natural gas. So if you drill an oil well, there is natural gas that's a byproduct of that well. And a lot of times, if there's just not an access to a pipeline, like you can drive a truck and pick up oil, but you have to pipe natural gas. So if it's in a remote area, they just burn the gas off and flare it. And so this is, number one, it's wasteful. Number two, methane escapes from the flare, which is a very high CO2 gas. And it's worse than CO2. It's a very high greenhouse gas. And so we can go directly to those wells that are flaring. We can capture that natural gas, convert it to electricity with a generator on site, and power a mobile data center that can then power this network that people are using as this new monetary network to trade value around the world. And so that's one use case that is not only has a great like ESG and environmental angle, but it's also just really cool, right? You can go and capture something that would otherwise be wasted. And there's lots of examples of this. For example, hydro-powered energy, renewables. I mean, the thing about renewables is that they don't work when you need them. They work when they work, right? So when the sun's shining or when the water's flowing or when the wind is blowing. And so there's lots of times when the power, the energy that renewables are creating doesn't match up to when we need to use it, right? The demand ebbs and flows. And so you can put Bitcoin and use it as almost like a digital battery or a virtual power plant where you can locate it at these sites. And so, for example, like Texas, where you've got this grid that during certain times, like if the wind stops blowing because it's really hot, they getting forced to have brownouts and even blackouts. And so if you could have a large scale source of demand like Bitcoin mining that could underpin additional base load, so you could say we could build a new power plant or we could build 3 new power plants, and when we don't need them, we'll be mining Bitcoin, which, by the way, converts this to a much higher value that you can store forever, has no shelf life. You can send it through space and time at the speed of light anywhere in the world and transfer that value to somebody else. There's just so many things you can do with it that you couldn't do with traditional energy. And then, by the way, whenever we need that energy, you can power the miners down and push it back to the grid. And now you've created effectively a battery or a virtual power plant. And so I could go on and on about the energy and how it's going to change things, but it's really just probably the most disruptive thing. And I've been in the industry for 11 years, so it's certainly the most disruptive thing I've ever seen, and something that I think has a lot of ways that can create a lot of good. One more example I'll use before I move on is, how much time do I have? I've got till the end of the hour. Okay, so one other example I'll use is like, you've got a lot of energy poverty in the world, right? So if you're in the Congo or somewhere in Africa, you may have a lot of natural resources. You might have oil and gas, you may have hydro, you may have access to energy. The problem is you don't have the infrastructure from a transmission standpoint to go underpin that hydro dam, because now you've got to lay transmission lines through the mountains or through the jungles to get it to all the different villages. And so if you had the ability to go to each locale or geographic area, build out a power source, and then you can't probably use all that power source, but you can use it to mine Bitcoin, harness that value, and then whatever left over, you can put it into the community. And if you need to turn the mining off to power more stuff in the community, you can. But it effectively acts as like an anchor tenant to support energy projects in different parts of the world where there may be energy poverty. So it sounds kind of crazy that could be something that could help energy poverty around the world, but it's already happening today. We're hearing about it in certain third world countries where people are going out at a small scale and taking energy sources and mining Bitcoin and using that as a source of revenue to help them from an economic standpoint, but then also used to power their villages and their communities. And so, again, just this idea that you can bring this really high value of energy and move it mobily around the world is it's just a thing it could change a lot of things. And so back to the total energy usage, you hear these headlines, Bitcoin uses all this energy. Like currently today, the network uses about 0.1% of the entire world's energy. So it's very small. And even if Bitcoin keeps growing at the rate that it's growing at, which it's growing at about 2 times the speed that the internet grew at from a disruption standpoint, it's pretty shocking. But even if it does, I mean, the most that we see in projections that it'll get to is still 0.1%. So this is a rounding error in the world's energy usage. It is using a lot of energy, but so does a lot of other things, right? Like clothes dryers use far more energy than the Bitcoin network. Consumer electronics use far more energy than the Bitcoin network. Hot tubs use more energy than the Bitcoin network. So the next time you read something that Bitcoin's accelerating climate change or is destroying the planet, this is just what we call FUD. It's a good headline that people like to click on it. But if you really look at it, the energy usage is not only the secret sauce and what makes this possible, it's actually a good thing for all the reasons that I mentioned earlier and what it can do in the energy markets. So talking more about the FUD, because this is what everybody likes to talk about. So you hear it all the time, like Bitcoin's the next tulip bubble. That's one that you see pop up probably every 6 months in an article. Why don't they, or the government's going to ban it. That's another one. So I'll talk on that one. I think Bitcoin as a money, and we're going to go in the next slide, we'll talk about what money is, but the government, what you're going to see is that number one, the government's going to tax it. They already are taxing it. You'll see governments like China that want to move to ban it and that have said that it is banned. And I think they'll probably put some regulatory framework around it. Maybe they will outright ban it forever, but people will ask me about that and they'll say, look, China's banning it. What's stopping the US from banning it? And my first response is usually, well, that's bullish, right? Because the governments are banning it. That means it's working. It's like doing what it's supposed to do, which is creating a new form of money, which they don't like because they want to control the money system. But the other thing is that governments are going to embrace it. So look at what Texas is doing. Governor Abbott keeps coming out and talking about it. They know that they're a big energy state. They've embraced it. They want to be the Bitcoin mining capital. I think Oklahoma needs to step up. We're working on that. Senator Ted Cruz and some of the other Texas legislators have been very vocal, speaking out about it. Senator Loomis in Wyoming has come out in support of it. So I think in the world where you see places with freedom, with pro-business, with places that want to facilitate trade, I think they will embrace this technology. And then you look at a country like El Salvador, which has recently made Bitcoin legal tender in the country, and they've mandated that everybody have to take it and use it for transactions. And so people say the government's going to ban it. Well, this year, a government made it their currency. And so that's the trend that we're seeing. And we're going to see some governments that won't like it, and we're going to see others that will embrace it. And I think that's true with a lot of technology. The other one is like, why don't they just create another Bitcoin? You've got Ethereum, you've got Dogecoin, you've got whatever other meme coin. that they decide to make. And a couple things. It's like, look, I could go create another Wikipedia. I could copy Wikipedia's source code and I could go and post it. And I could pump a bunch of marketing dollars into it, right? And say, hey, everybody use my Wikipedia. Like, no one's going to use my Wikipedia. Like, it's just, there's a thing called a network effect, which people in here probably understand. But it gets back to the energy usage. Like, the Bitcoin network is so robust and it's growing at such a rapid speed. Like, right now where the Bitcoin network is at, it's about where the internet was in 1997. And this is a stat that people throw around. I don't know if you guys have heard it, but it's growing at 2 times the speed of the internet. So where it's at today is very, very early on, and that network effect is continuing to grow. And so, the other thing about it is that, like, these other altcoins, they're trying to do something that Bitcoin's not. I would almost like equate them more to like a company or like equities. You got like Ethereum 1.0, 2.0. They got a new team of developers like Solana and all these other coins, and it's changing all the time. They're upgrading it, they're printing more, and it's like, I don't know about you guys, but like, I don't want my money to change. Like, I want my money to be the same money that I had 2 years ago. I want it to be the same money next year. I don't want like a 2.0 version of my money. I want my money to be sound money that I can store value in. And so I think that a lot of these cryptocurrencies are very, very centralized. They pretend to be decentralized because they're on a blockchain. But at the end of the day, they are controlled by a small group of people that can have massive changes to them. And even if they were totally decentralized, they don't have the powerful network effect that Bitcoin has. Now, that doesn't mean that there won't be other coins. There obviously are and will continue to be. But I just think that long-term Bitcoin will be the gold standard, for lack of a better term. So, and we can talk about it. I want to open it up to questions, so everybody tell me why I'm wrong here at the end. So accelerating climate change, I already talked about that one. What if Bitcoin gets hacked? We talked about that. It's be very difficult to do, if not impossible. People never use it for transactions. That's another good one. It can't scale. They're starting to in places. And I mean, any new currency, like, it's going to take time for adoption. And so we're seeing things like the Lightning Network, which is the second layer solution. It sits on top of the blockchain. It effectively batches transactions, so you can do microtransactions. So you can send fractions of a penny. So I've got a buddy who has a podcast, and he has people streaming him what are called sats, which are the smallest divisible unit of Bitcoin. So there's 100 million sats, like Satoshi's the guy that found it, like cents. It's kind of a play on the word cents, but he can get these streamed to him in real time. So this is something we could never do with dollars. I mean, Visa is going to charge you. And it's the reason why you have to do a monthly subscription fee. But with Bitcoin, because it's just so costly to do these charges, but with Bitcoin, you could literally stream it in real time in tiny, tiny fractions of a penny. And so, maybe there's a future world where you don't pay for cable or for listening to music. You pay as you listen, and you pay just fractions of a penny to listen to your favorite song. And then all over, you go the whole month and you've actually paid less than your Spotify subscription, because this technology has allowed you to create less friction with money. So I think the transactions will come as adoption picks up. Bitcoin isn't backed by anything. That's a fun one. We'll talk about what money actually is here on the next slide. It's a Ponzi scheme. People have to keep buying more of it, and it can't go up forever. And so the interesting thing about Bitcoin is that the price or the supply is totally fixed. So there's 21 million, and it is going to continue to go exponentially down in supply. Right now, about 90% of all Bitcoin that will ever be created has been created. The last 10%, the majority of that will be within this decade, and then the last 1% will be over the next 120 some odd years. So it is an incredibly scarce asset that is getting much scarcer all the time, and demand, again, is growing at 2 times the speed of the internet. So, I don't know what will happen to the price of Bitcoin. Certainly in the short term, it can drop very fast and go up very fast. But, basic supply demand models like we use for oil or for gold or for any other commodity will show you that if demand is increasing and supply is decreasing, price does one thing. It goes up over time. So again, we can argue about it, but that's been the track record. It's been on average, it's gone up about 200% compounded annually per year since inception in terms of the price. And I think we're going to continue to see quite a bit of appreciation. So 2 more slides and then I'll open it up. So what is money? Money has characteristics that we can measure. It's not just, the government prints this thing and says it has value. Money actually has characteristics. And so you can look at this list on the right. It kind of compares gold, fiat money like the US dollar, and Bitcoin. It has to be fungible. You can interchangeable, has to be non-consumable. So for example, if I'm trading you a piece of bread, well, that's going to go bad pretty quickly. And people used to trade food back in the day in the barter system. Portability, you have to be able to move it from place to place. Durability, excuse me, has to be able to be durable. Divisible, Bitcoin's highly divisible. It can be divided into 100 million units. Secure, Bitcoin is, right now impossible to be hacked as long as you have your private keys. There's no computer on the planet. It would take, you'd have to run this highest power supercomputer, for millions of years or something. I don't know the exact stat, but it's be very hard to break it. Maybe quantum computers could. We could move to a more higher level of encryption if that happened. Scarcity, easily transactable, decentralized, and smart and programmable. So these are just some of the things. People have traded things like seashells, livestock. Gold, for example, is a very good proxy to Bitcoin. People say, well, what is Bitcoin backed by? Well, it's like, well, what is gold backed by? Like gold is a perfect example of a completely non-government backed, totally just organic thing that became money. Like the reason why it became money is because it had these characteristics. It's because people need something to exchange and to store value. And so over time, humans tried a lot of different things and they settled on gold. And the reason why they settled on it was not because some grand government conspiracy that everybody's going to use gold. They settled on it because it checked a lot of boxes. It checked all the boxes here on the right. And so, if you look at the traits that money has, there is still an element of it, which is what most people have the biggest struggle with. And that is that money is like belief system. Like at the end of the day, like it can have all those traits, but like if you don't believe in Bitcoin and you think it's a scam, like you're not going to buy Bitcoin. You're not going to store your value in it. You're going to store it in dollars or gold or collectible cars or whatever you think that you like to spend your money on. So I think that from the belief system standpoint, that's the one thing that I've really seen that is been impressive with the Bitcoin community is that the people that understand the technology and that have been involved with it since it early on are very, very passionate about it. They very much believe that it is a store of value. And there is virtually, and I know a lot of these people really well in the community, and there is virtually nothing that you could say or tell them that they do not believe that this is the currency that's going to power the future. And so if you look at the belief system for the people that have studied the technology, you look at the characteristics of Bitcoin, there are a lot of people that will argue it's the best money that's ever been invented. Again, tell me why I'm wrong here at the end, but that's the reason why they say that is because of these things, right? And then the moral case for Bitcoin, and I've got about 15 minutes left, so I'm going to go. So I truly think that Bitcoin can make the world a better place. Some people that don't know anything about it say that they're like, you're crazy. Like it's just fake money on the internet. But I do think that having a sound monetary system and be able to store your value should be a basic human right. According to the World Bank, there are 2 billion adults that don't even have access to a checking account, don't even have any basic banking whatsoever, don't have any way to store money, any way to store value. That is a huge chunk of the population. It's also estimates show that 80% of people on Earth, which I actually would argue it might be 100% of people, either live in a country where it is state-owned or like totalitarian type banking system where you don't really own that property, or you live in a place where there's double or triple digit inflation. The reason why I'd say it may be 100% is because, look at the US right now. They're saying it's 6.5%. I think, I bought my truck 2 years ago and it was around $40,000, and that same truck, same exact specs is $75,000 right now. So you can tell me that inflation has been 6%, but I've seen my purchasing power, whether it be a house, whether it be a car, whether it be the food I buy at the grocery store, I've seen that just completely be decimated over the last 18 months. 35% of every dollar that's ever existed has been printed in the last year and a half. They're talking about printing even more. It could be close to 40% of every dollar ever in existence has been printed just recently. And it's not just this administration, it was the one before that. It's fiat. They can print as much of it as they want. And so inflation hurts poor people the most. I think that when you think about money, and I'll use like my parents as an example, they worked for 30 plus years to retire, and they were very conservative with their money, tried really hard to pay down their home, to put money away so they could retire. And if the government prints 35% of the money with the push of a button in their purchasing power, again, you can argue whether it really is 30%. I've seen certain things in my life that have gone that much inflated in the last year. But if with the push of a button, you can devalue the currency by 30%, that's effectively like stealing a third of their entire career. They lost 10 years of their life in the last year of the money that they've saved. Now, luckily, they have assets like stocks and real estate and things, but not everybody has that, right? So what inflation does and what money printing does is it makes the poorest people and the people without assets, or the conservative people that don't want to put their money in stocks, it punishes them and it makes the wealthy wealthier. And you can see from the 1970s when we got off the gold standard to today, the wealth gap has exploded. And the people with assets, the more money they've printed, they've gotten richer and richer. The 1% has gotten so far ahead of everybody else, and wages just haven't kept up. And so that, all coupled with the fact that Bitcoin's censorship proof. And so this is the last point, is that, we're living in a time where free speech is, I would argue, kind of under attack. I mean, whether it be in social media or mainstream media, some people may argue with me again there. I think that there's a lot of instances where we've seen personal liberties kind of attacked. And so just having a technology where you can say this is objective, nobody can mess with it, it's set in code, and it is objective truth. Like the blockchain has been validated, it's been proved through the proof of work, and there's nothing anybody can do to change it. Again, there's just nothing like that. So I think that can do a lot of good in the world. I think it can open up banking and access banking to a lot of people that don't have it. If you look at the highest areas of adoption, it's in places like Nigeria. It's one of the highest adoption areas of Bitcoin. Their government was corrupt. It was corrupt the banking system, and they've moved now to using Bitcoin as their medium of exchange. So these are all the reasons why, again, I think it has the potential to be very disruptive. If you'd have asked me in 1997 to predict Netflix or Uber or, social media, nobody in this room could have predicted it. Maybe someone could have had an idea. And so that's how I think about Bitcoin. Like, I can't tell you all the things it's going to change, but I think it's going to change pretty much everything because money is the basis of everything we do. So our company, Ankova Digital, we are turnkey Bitcoin solutions. We're doing Bitcoin mining. We have our own mines. We help our customers mine. We do a wide variety of things. This isn't an ad for us, but just wanted to tell you about us. If anybody wants to know more, you can hit me up afterwards. And that's kind of all I got. So open it up for questions. I got about 12 minutes. If anybody's got one. Go ahead. Yeah, so the question was for people that couldn't hear is that how does Bitcoin kind of act like a battery? And I don't know if battery is a perfect example, but effectively they are taking energy that would otherwise be wasted and then turning that into a monetary value. So they're not going to use that energy later. But for example, you can use the value of that energy, capture that value, which then allows you to have a more robust, for example, base load. So like the power plant example, it's like if you needed to build a power plant, you need lots of base load to have things like renewables. So this big push towards renewable energy, you have to actually increase the base load a lot because the more renewable energy you have, it's more intermittent, which causes there to be these fluctuations in the grid. And so Bitcoin could act as that stabilizer to where that's that buyer of last resort and first resort. So whenever the wind's not blowing or whatever, you can use that energy to push towards the grid. Whenever the wind is blowing and the sun's shining, you can sop up that energy in the Bitcoin mining and store that value, and it turns it into a monetary value. And then that power plant provider can take that and use it for different things, but it makes them stronger. Does that make sense? It's not like they actually can use so it's an analogy. It's not really a battery, but yeah. And what else we got? Go ahead. I think it is a store of value. I think that it will over time be more of a currency. I think right now it's more of a store of value, and primarily because it's still so early. I think, people see Bitcoin and the question was, do I see it as an investment or a store of value for people that didn't hear? But I think that today, because it's so early, people get like unit bias, right? So you look at 1 unit of Bitcoin and it's 60,000, 50,000, whatever it is today, 55,000. And then you look at 1 unit of Dogecoin or pick a meme stock or meme coin and it's 30 cents. I don't even know what it is. But they look at that and they say, oh, Bitcoin's already here. It's, I've missed that whole thing. It's, I'm going to go invest in this other thing that's 30 cents because you have a unit bias. But take into account all the things I talked about earlier, I think Bitcoin still has this huge running room in terms of where it goes in value. And I think that at some point the market cap will get such to where the volatility decreases pretty significantly. Probably it'll take a decade or more. And then at that point, you'll see this stable value that will march upwards slower over time. The supply, again, we're seeing these big supply shocks. So right now they have, the program is there's a halving every 4 years. So every 4 years, the supply of new Bitcoin that's mined cuts in half. So you see these big supply shocks. And so you see the price of Bitcoin shoot up. And that's what happens this last halving. It went from, $3,000, $4,000 up to almost 70,000, 69,000, right? It's because the demand is growing, like I talked about. And you're seeing these big supply chunks going away every 4 years. In the future, once like 99% of it's mined, you're not going to have these big supply decreases anymore. It's going to go from, oh, this year we have this little bit, and yeah, there'll be half as much in 4 years, but half as much will be a smaller percentage of the total. There'll be more in circulation. And I think the market cap will be bigger at that point to where it'll be more stable. So today, A lot of people view it as an investment. I view it as, I guess I would say, a store of value. I do use it as a currency, but I use it as a treasury asset, so effectively a store of value. And then I think as it stabilizes and gets a higher market cap, you don't see these crazy fluctuations. I think people will transact with it more, especially in these places where they need a good medium of exchange, right? Like in the Western world, we can go open up a bank account. It's easy. I can use my Apple Pay. A lot of people just don't have that. So I think it'll be both, I guess, is probably the best answer. I bought different things. I mean, certainly in the Bitcoin community, people want to use it as transactions. So like if I get my tickets to the Bitcoin 2022 conference, they give me a big discount if I buy it with Bitcoin. So I'll use it for that. I'll use it for things like, I think if you're international travel, if people take Bitcoin, it's really nice because you don't have to convert it. It's universally accepted. If somewhere accepts Bitcoin around the world, like if I went to El Salvador right now, I could walk into a McDonald's and I could buy a meal with Bitcoin, just scan the QR code with my phone and it pays for it. El Salvador is not the best example because they also take dollars. But if it was another country that didn't take dollars, a lot of people don't know this, but you can't Venmo internationally, right? Like you can only do it with dollars to dollars. In fact, it's really hard to transfer money between currencies. They make it difficult and it's expensive. There's exchange rates and all these things. So I think the use case for buying stuff and using transactions is more of a worldview. And I think that it will get there as adoption rises. But today it's just still really early. So that's kind of the nice thing, is that it's a uniform unit of exchange. Yes? Yeah. Sure. Right. Yeah, definitely. So the question was, regulation is how does that affect adoption of Bitcoin? So there are hardcore Bitcoiners that like don't want it regulated. They're like, hey, don't mess with my money. Don't mess with this stuff. There are more moderate Bitcoiners, especially people that are like institutional investors or people that, like, for example, if you're a big endowment fund and you want to buy Bitcoin because you think it's a good store of value, like you would gold or something else, you may be afraid to do it because you're like, I don't know what they're going to do. Are they going to tax it weird? Are they going to do all these things? So I think that there is a case to be made for reasonable, transparent regulation that people know what's going to happen, right? And, for example, right now, like when we mine it, I think it's taxed really bad. They tax you when you mine it, and then they tax you again when you sell it, and it's a pain because they say it's not a currency, but they tax it like one, then they tax it like an asset later. So, but at least I know what it is, right? I don't like it, but I know how that goes. So the more adoption and the more that these bigger institutions, like the banks, are all getting really involved now. You're seeing a lot of the big names starting to play in the space. ETFs are getting approved, so that's like an investment fund. And so as those things happen, there will be regulation. And I think in some ways, if it's sensible regulation, I hope that it's a good thing for people to get more comfortable and there can be more adoption, is what I would hope. I mean, it's taxed like both kind of now. I mean, I wish, so like when I produce a barrel of oil, if it goes into a tank, we don't pay taxes on the oil until you sell the oil, right? Or gas too, you could put it into storage. If you produce a Bitcoin, you're taxed immediately as if it was dollars, right? But they say it's not a currency. The government goes out of its way to say this isn't a currency, but we're going to tax it like a currency. And then when I go to sell that Bitcoin, they tax me again as a capital gains tax. So that's why I said I wish it was like more like a commodity, I think. And I haven't thought through all the ramifications of that statement, but in my mind, from somebody who sells commodities, I would rather it be treated as I get taxed when I sell, or maybe there's some period of time, like at the end of the year, I got to sell it or I didn't pay. I don't know. I wish that it wasn't just taxed the way it is now, but it is what it is. So, go ahead. Yeah. Right. Yeah. So the question was proof of work versus proof of stake. And I probably don't have all the time to go into what proof of stake is, but essentially proof of stake is another way that they're trying to solve the burden of proof. So how do you know that this block is valid? So right now it's proof of work, and this is what Ethereum uses as well, but there are a lot of new coins that are using what they call proof of stake. And so the solution that they came up with is that you just stake money, you stake coins, so you put them in, you lock them up effectively, and then you then have to validate that the blocks are real. And if you're a bad actor, then you lose the coin that you staked and you potentially even get kicked out of the network. So it's another kind of hammer mechanism to where basically people won't cheat because they'll be staking their coins rather than spending the energy. And so people have said this is going to be what could replace proof of work. I think the biggest problem to me, and we're seeing it through, there's a couple problems. One is that proof of stake is very complex. So a proof of work, you can, and I'm not a coder, but from what I've read, it can be coded fairly simply. It could be like 100 lines of code to do the proof of work. And whereas proof of stake, it's hundreds of thousands of lines of code. It's very complex. There's lots of backdoors and different ways it can be attacked. And so that's why Ethereum's taken so long to launch, is because they just keep coming up with, people keep coming up with ways to poke holes in it. The other thing about proof of stake is it has a very, and this is the big problem, is that it has a very strong centralization effect. So if you're Amazon, you decide, I want to control Ethereum, which most of the nodes are hosted on AWS anyways, they could just come in and stake fiat. And what we talked about earlier is fiat is infinite, right? So if a government wanted to stake fiat, they can just print fiat and they can stake it. And now they can be the largest stakeholder on that blockchain. And proof of stake is perpetuating, it snowballs, right? So the bigger stake you have, the more of the network you control, and it snowballs over time because you can keep staking, and your stake, you get rewarded for what you staked. So if you're the guy, like Apple comes in and stakes the biggest amount, now they've got the biggest snowball. Over time, that snowball is going to get bigger and bigger. And what you'll see in proof of stake is you'll see a network that is not all that decentralized. It's controlled like an oligarchy. I can't even say the word right. But yeah, oligopoly. Golly, that one's bad. It's like an oligopoly over time. Those are the arguments. I'm not an expert on proof of stake, but I've read some. Lynn Alden, I believe is her name. She has a really good article on proof of stake versus proof of work. It just came out this week. If you hit me up afterwards, I can send that to you. And she does a really good breakdown. I mean, it's probably like a 20-page article or 15-page article, and she breaks it down. And she's been a big proponent of trying to look at proof of stake, but her conclusion is effectively that it is has some centralizing effects that could be a problem over time. What else we got? Go ahead. I mean, the biggest problem that I see today in Bitcoin is that and I don't want to sound like too much of a Bitcoiner, but I think it's just the misunderstanding around it and not understanding what the technology is, and people effectively looking at it as something that they don't get it for whatever reason. I think the bear case for Bitcoin is if for some reason the proof of work mechanism were to break. So if like so hash power has been increasing over time as it's designed to do, which is computing power. In short-term periods, we can see computing power dip, like when there's a bear market. If we went through like a long-term, prolonged time period where hash power is continuing to dip and trending downwards, I don't think that would be good for Bitcoin. I think Bitcoin, it needs to get more computing power. It needs to get more robust, because if it's going to be a medium of global exchange, then I think it needs to have more robust network. And so if the network is getting less secure over time, I would say that would be a red flag, which we haven't seen that. The other negatives I could think of, I mean, really, like a lot of the stuff, the FUD that you read, people say like they use it for crime and all that stuff. It's actually really transparent. I mean, if you ever make a Bitcoin transaction to do something illegal, like it's there forever. Like that's on the blockchain for all of eternity. Someone can track that. Far more crime is committed with US dollars than Bitcoin, like way more, in cash especially, because you can't trace it. So I don't know. What do you think? Do you have anything that specifically that you're thinking that could be a negative? Maybe I haven't thought of it. Yeah. For sure. It's a lot to think about. Yeah. Right. For sure. Yeah. There could be some of that. So that definitely could be disruptive, which not be a good thing. And I'm out of time here in a second. So the last thing I'll say is that
Hey, welcome back to KubeCon, Cloud Native Con in Valencia, Spain. I got a great crew here from StormForge. It's great to be talking with you both. I don't think I've had either one of you on one of our sessions before, so what a better way than to break you in at KubeCon and you know,
absolutely
in Spain, you know, go for it. So Tom, introduce yourself, tell us a little bit about you, and then Patrick will have you do that too.
Hey, I'm Tom Ellery. I run worldwide field operations, which includes customer success, revenue, a host of other things with the technical side. Been with StormForge now a little over a year. I've got 6 startups under my belt. I've been in high tech for, probably shouldn't say this, but close to 35, almost 40 years.
Yeah, we stopped counting at 30. So
Thank you.
Good.
Yeah. So edit that out, please.
You're good. Yeah, 30 plus is what we say.
I love it. It's amazing.
Nice. Okay, Patrick.
Yeah, Patrick Bergstrom. I'm the new CTO at StormForge. Not quite as much experience there as Tom. This is actually my first startup. Before that, I was with the enterprise, Fortune 10, Best Buy, United Health Group, all kinds of fun things. And I've been here for 6 weeks, so still getting my feet underneath me, meeting a lot of customers, doing a lot of travel. It's been a lot of fun.
This is the fast part of the river.
Yeah,
you know,
right. Eventually I'll catch up and it won't feel like it's whitewater rafting anymore.
You get all the rapids too.
Yeah,
but yeah,
exactly.
It's definitely a different pace.
Yeah.
I totally get. So one of you tell folks about StormForge, just if, you know, we've had you all on before and talked about some very cool things that you're doing, but if you want to
I'll start and then I'll let Patrick weigh in. He can give it from kind of a customer's perspective. I'll give it kind of from the market perspective. So the one thing great about StormForge, when you start looking at Kubernetes, KubeCon, there's a fair amount of complexities when people start deploying applications in a cloud native environment. And people are struggling today to try to figure out how they manage cost with performance. Our platform is an optimization platform that allows you to actually look at those trade-offs and not have to give one or the other away and balance those two between cost, performance, which ultimately also leads to quality of code coming out, ensuring you get your releases out on time, and making sure you don't run into critical resource shortages as you're deploying applications inside of a cloud native environment.
Yeah, it's an important problem space because I remember just going to the cloud, it's sort of a leap of faith of how much do I need? I'm not buying hardware, but you know, is this stuff going to suddenly max out my credit card overnight or my, you know, my invoice or whatever?
Yeah.
And kind of same thing with Kubernetes. It consumes a bit of resources. And you need it to when you need it to, but not all the time, right?
I think the interesting, so I've worked in virtualizations for a while. The thing that you saw in virtualization with trying to balance resources with the deployments of applications is now accelerating with Kubernetes. And so we're almost repeating the same issues that we had early on with virtualization.
We've never done that anywhere else in our industry.
And so we're trying to get ahead of that curve where you're more proactive than reactive in solving the problems that customers are going to have, and they just don't have visibility of when they're going to happen.
Yeah, we talk a lot about helping teams accelerate their day 2 operations, right? Because it's like you said, Kubernetes is very complicated. The number of configurations that exist there that you have to know what it does is crazy. And that's one of the things that actually really drew me to StormForge as a customer, and then also now obviously as their CTO, is it's true machine learning, and so that helps us eliminate the human bias, which I think is fantastic, because there's been more than one occasion where we've made a recommendation for a configuration, and the human behind it said, well, why would we change that? That doesn't make any sense. And then they tried it, sure enough, huge performance impact. It's been fantastic. It's really interesting.
Yeah, it's something too, and I remember a point in my career, not every developer thinks about tuning, right? Like the Java virtual machine or whatever environment. It's kind of resources are resources, and there'll be more when I need it, which, that's nice too, but it isn't truly infinite, and it certainly isn't free. I would imagine that you came out of the healthcare industry prior to this, right? They're pretty cost conscious. They watch the dollars closely, right?
Absolutely, and it's especially when I wear my SRE hat, and I hate how much I say this phrase, but it's true. I do it a lot. If you give an SRE a Kubernetes environment and you say, hey, your application has to be available 4 nines, they're going to turn that CPU dial all the way to the right, because that's how you get that, valid availability and reliability concerns, is just how much CPU can I throw at it.
So you're saying StormForge is give an SRE Kubernetes or give SRE StormForge.
Right, and that's the idea.
Teach them to fish.
Exactly.
That's where I was going for.
Yeah, and that's the idea. We can come in and we can tell you, hey, you want 4 nines, this is the configuration you should use.
and then that'll save you X amount of dollars, because every core of CPU beyond this, or memory, or whatever metric you're looking at, isn't doing you any good other than helping you sleep at night, but you don't need it.
So I understand we have an exclusive. You're going to tell us about a big.
I won't. I'm not going to tell you the exclusive. I'm going to let the
right
CTO tell you.
Your Matt was here, was like, do it, guys.
This is what he does. He puts me in front of a camera and gets me to talk about new features. Yeah,
your new role.
So then I have to commit to delivering that later, right? But one of the biggest things for me, as coming from the enterprise, is the cost of Kubernetes and how much of that is just. Like I said, it's wasted because people are cranking that dial to the right, and so it's too much CPU compute, ends up being a ridiculous amount on your cloud bill, right? And so one of the things that we're working through right now is this product that we call Illuminate, and the idea is essentially we're going to provide transparency into what you're spending on Kubernetes, and then we'll also be able to natively identify for you the areas of your application, or maybe within your namespace, the ones that are costing you the most, and say, hey, this is one that you need to look at right now. And so it'll help you prioritize where you start by using StormForge. And then also we'll be able to track that over time. Because that's one of the things I love about StormForge, is especially when you look across like a cluster deployment, 99% of the time, in fact, I don't know that we've had a customer yet where we don't save them money. Like, it pays for itself.
Well, we love to over provision,
yeah.
so you're
everybody. It's crazy.
It's that safety net, right? Yep. But how big a safety net do you need?
Yeah, not to the tune of some of the ones that we're seeing, where we're saving millions of dollars for customers. It's crazy, and then it has it kind of has some impact to the environment too. When we think about wasted compute cycles, reducing power consumption, all that fun stuff, and then or like if you're at a physical data center like we have at United Health Group, our data centers were literally full. We were out of space and we didn't want to build another one. Well, with StormForge, we can come in and free up that CPU, so then you can deploy additional namespaces, so that you don't have to worry about trying to figure out where you're going to rack another server to get that one more cluster in there. So.
Did I understand correctly? It sounds like you're looking into the application part of how it's consuming, or orchestrated, organized through Kubernetes, which, let's face it, you can have nice big fat containers, you can have really sleek, efficient ones, and microservices and service mesh, and it's all in that design. And I'm sure, large enterprises don't go rewrite all their apps in Kubernetes and highly efficient microservices tomorrow.
Right.
It's just a fact of life. New things might get that advantage, but you've got that blended environment where you may be running some less than efficient, but there are more ways you can save money on that, as well as your, maybe your high performance apps.
And what's really interesting too that we've seen when you have a big cluster deployment or a ton of namespaces, more often than not, we'll find one or two that are actually under provisioned, just because all these big ones are over provisioned, they're using all the CPU compute, and so then the little guy at the end of the day, there's not enough left for them, and they'll maybe deprioritize it from a reliability perspective, but then when we save 30, 40% off the top for the rest of the namespace, then suddenly we can come in and say, hey, this application, actually, we think you need to deploy a little bit more CPU, a little bit more memory, and then this is what you get for availability and latency as a trade-off, and it's improvements with a minimal cost improvement on just that one application, which is, it's great. It's all these unintended consequences that I love about the capability.
Interesting.
It's interesting when you look at the legacy applications that you brought up. Java's a great example. Java has so many different parameters that you need to tune when you pull it over. Heap, garbage collection, replicas, the list goes on. And if you look at Kubernetes environment, it has all its own variables you need to tune. So the fact that you need to tune these things in concert to ensure that you don't have an outage, like you talked about, customers have outages because they run out of resources a lot of time. If you had a tool like a optimization platform that could do these all through machine learning and not have humans try to do the dials, the likelihood of success goes up dramatically. And that's really been our sweet spot, is looking at those type of deployments and environments to solve against.
And Matt your CEO, has a great story about kind of his time collecting ideas and working on some machine learning and where to apply that, and kind of ended up in the Kubernetes space.
Yeah, it is. It's an interesting journey. As most startups, you pivot a couple times in order to solve the problem, but if you looked at the level of complexities in how ML could actually solve those complexities, and I think in today's industry, it's a little bit of a challenge. Everyone and their brother uses buzzwords around AI and ML, and a lot of them aren't trying to solve a real business problem. And our whole practicality is, where is the business problem that we can help solve? And the Kubernetes one felt right in our sweet spot from a technology-based standpoint.
Well, and that was one of the things for me when I joined the company and I was first looking into it too. It was, I looked at that and I said, I've had this problem for 10 years. Like, this is perfect. Like, I love it. Which got me really excited about what we're doing. And yeah, like Tom said, we started in machine learning. So it's, because one of the things I like to talk about when I was at the enterprise and people would come in and sell to me, it's like, oh, we have this thing, it's machine learning, and then you look under the covers and it's just a Holtz winter forecast and a trench coat. It's like, well, that's not really machine learning, right? But with what we do with this product, it's, like I said, it's true machine learning. We've got our own algorithms that we wrote. I've got PhDs in applied maths on staff that just love this stuff. And the story is so cool about where it came from.
Cool. Well, I'm not going to be Matt and pin you down to an exact date when you're launching this.
Yeah.
Yeah, it's like
he would want it tomorrow, probably, yeah.
Well, you know, tomorrow afternoon would be fine.
Yeah.
Do you have an idea on time frame? Kind of generally, plus or minus 12 months?
Oh yeah, for sure.
I'm going to be really generous.
Yeah,
No.
I don't know if I would still be here if it was plus 12 months, right? If we don't deliver on it. But no, it's a big priority for me because when I think about who I was as a customer at the enterprise, it's very much okay, what is this doing for me? And to be able to show somebody in a Grafana dashboard, here is the amount of money that you have saved, and then also here's the other amount of money we predict we can save on these other applications. Like it becomes a no-brainer for me. So my hope is soon, right? Tom would say, can you get it next week?
As always, that's what I would ask for.
Yeah,
but I think the marketplace is growing like crazy, as you're aware, and there's so many tools out there that talk about cost, right? And one unique thing about us is it's not just the cost, it's about the trade-off between how much resources and how you want your applications to perform. So you can try to only solve a cost problem, and you're still going to have other OMM and other issues that you run in from a production standpoint. So we want to actually have a platform that not just looks at cost, but it looks at performance, looks at quality, and it's all doing it through an algorithmic way. And so the humans are a little removed from the day-to-day tuning and solving of it, and could actually prioritize higher innovative things within the framework of developing software.
Yeah, very good. Well, hope we see something in 2022, or
my hope would be I think we got right.
That's the best I'm gonna do.
He's holding him to it.
I doubt I'm going to get better than that.
Right? When's KubeCon North America? Right?
Detroit.
Yeah.
Hey, you're doing it to yourself. That's not me.
We'll see you in October.
All right, Patrick and Tom from StormForge, thank you so much for being with us. Good to have you on Techstrong TV. Come back. We want to hear more about Illuminate.
Sounds perfect.
Thank you.
Thank you.
Thank you. Stay tuned. We have more coming. We have some really fantastic interviews in addition to this one, of course. And thanks for joining us. We'll be back real quick. We are back, and I'm very pleased to be joined by Rick Spencer, who's VP Product with Influx Data. Welcome, Rick.
Thank you.
Would you give us just a brief introduction of yourself and tell us about Influx Data?
Sure. So I was actually the VP of Engineering for the platform team for about 2.5 years at Influx Data. I recently moved over to the product role. Been in open source software for quite a while before that, Bitnami, and I had a long stint at Canonical. And then before that, I actually worked at Microsoft in developer tools for quite a while, but that's going way back.
Dipping back a little farther there. Well, tell us about Influx. Influx Data, yes.
So at the heart, we're a time series database. We're quite well known for our open source offering, and that's used in quite a few scenarios, very heavily used. We have some tools around that like Telegraph for people writing agents to sync data and write data back to their InfluxDB instances and et cetera. Of course, we have an enterprise product. But right now our flagship product is InfluxDB Cloud, which is a fully hosted multi-tenant SaaS solution. So it's pay as you go. So if you're a developer, you have a time series use case. If you're writing a time series application, just come sign up for an account. You can start on a free tier and then just pay as you go. As your app, as you consume more and more, you pay more and more, but on days where you don't consume a lot, you don't pay a lot. And so we've been getting a lot of traction on that, people building applications on top of us, a lot of IoT, a lot of server monitoring, and a lot of finance actually. So all those kinds of organizations produce a lot of timestamp data, very high resolution, and so they send it to us in the platform and then build their applications on top of that.
Well, and I imagine it's not just the data collection of all that, because obviously some of those situations generate large amounts of data. It's a synthesis of that, and maybe collecting that from different locations across the cloud or your data centers.
Yeah, exactly. So just to clarify, since we're at KubeCon, we don't really think of ourselves as a Kubernetes tooling provider, but we do have a lot of customers who monitor their clusters using InfluxDB, and we also have a few companies that have built Kubernetes monitoring or SLO as a solution on top of us, like Noble9 and some other companies like that. So they can send all that data to us from their customers, and then we have a language called Flux, which is this programming language, which is integrated into InfluxDB. So if you're doing, monitoring, but also if you're just doing like crazy data transformations, Flux has like a very rich math library. It has the ability to pull data from other data sources, other DBs, alert, push it back. So you can write all of these programs in Flux and actually just push that down into our platform and let our platform run all those functions for us.
Well, I'm really tempted to ask if you have a flux capacitor going back to the future.
We do have a product called Capacitor.
Do you really? Okay, perfect. I'm so glad to hear that, actually. Well, we were talking earlier, and I came from a briefing where they were talking about Kubernetes in the telco space, and one of the premises was that the edge computing, edge cloud, you talk about a distributed situation, and I refer to it as kind of pop-up data centers, pop-up services, pop-up networks, pop-up applications.
Yep.
To overuse that word a little bit. But that really is kind of one of the scenarios around the cloud, whether it's collecting data from your Tesla or from your home automation systems or whatever might appear at the edge.
Right, so we're seeing this a lot in IoT, but also in other scenarios like in server monitoring, or more likely cluster monitoring. So we have actually an OSS version which you can run as a single node. It's super easy to deploy and manage. And so what we've added recently is a feature called edge data replication. So imagine you have, let's say, 20 windmills, and each of those windmills has 10,000 sensors. You can deploy an edge node of InfluxDB, just an OSS node, super easy, stand it up there, collect all that high fidelity data from those 10,000 sensors and then do all your local processing there, whether it's control loop, that's local, alerting, everything. But then you can also sync that data just with a real easy configuration with our edge data replication feature and send it back to a central cloud account. So you can sign up for InfluxDB Cloud, distribute OSS node on all of your windmills, manage those all locally. You can even log into them locally if you want to visualize how it's working there. And then you can downsample that data, enrich that data, and then sync it back, and then look at all of the 10 windmills globally from your cloud account. And you can also have retention policies for that data that are appropriate for long-term storage and that sort of thing.
What would be a good example of downsampling? Is that just kind of identifying what the most common occurrences are, or is it doing some correlation to tie to it events or things like that, or some of both?
So downsampling is a way of reducing your data. And the reason that's important for time series data is you have to remember there's very, very high resolution, very big volumes of data. And so there's really two kinds of downsampling. And the first is to remove cardinality, right? So if you're looking at a Kubernetes node, you care at that moment about things like what is the identifier of that specific pod, for example. But over the course of the day, you could have 1,000 pods, 2,000 pods. The next day, you only care about the role of that pod. So you can downsample by removing that column before you sync it back to your cloud where you're looking at it globally, because you just are interested in the health of the service, not the health of a specific pod at that point. Another way of downsampling is to remove what I would call rows by aggregating data. And this is really where InfluxDB really shines as a time series database, is it's very easy to say, just give me an average for every hour, every minute, every second, or whatever aggregate function you want to use, min, max, mean, whatever custom function you want. You can aggregate into those time windows and then sync those time windows back. It's not just that it's much less data, which it is, it's also much faster to query it, and it's often just much easier to model the world in terms of what was the average over the minute instead of what was every nanosecond of data that we got. So those are the two kinds of downsampling that people do from the edge back to a central account.
Cool. One of the things I was wondering too, you always think about the new things as we're deploying in IoT and at the edge. There's a lot of existing equipment, SCADA, whatever you want to look at. Windmills have been out there for a while. Some of those things use non-guaranteed delivery protocols like UDP. It's great to sample, great to collect data locally there, and then do processing, aggregate it, downsample, synchronize it, that kind of thing. So there's a lot of reasons, I think, to look at the edge, not just for new applications, but also existing ones.
Yeah.
Is that something you find with your customers?
Yeah, well, we actually really on that data replication feature, we really focused on having a durable queue. So as long as you can get the data to InfluxDB, if you try to replicate it, it will get replicated, even if your internet connectivity goes down, even if the whole system reboots. It's a very durable, file-based queue to ensure that the data does eventually get there. And we see people use that for scenarios where they expect intermittent connectivity. For example, if you have a ferry, tons of sensors on the ferry, you need to know how the engine's performing and all kinds of data that they collect, ton of sensors, and they do a lot of local control while the ferry's crossing. It loses internet connectivity, but then when it gets to port, it regains connectivity, and they really want to guarantee that that data gets synced back to a place where people can monitor all the ferries all at once and aggregate across all the ferries. So we focus on that quite a bit, yeah.
Well, it's kind of logical to see that as we're scaling up more and more Kubernetes or similar kinds of technologies, we have to have data technology schemes that scale as well.
Yeah.
From that standpoint. Well, good. It's great to talk with you, Rick.
Yeah, ditto.
Hope you have a really good show here for Kubernetes and non-Kubernetes opportunities.
Yeah.
Great. Well, thanks to Rick Spencer, who's VP of Product here with Influx Data, and good to have you on, and always happy to have Influx here visiting.
Great, yeah. I'm looking forward to seeing you again.
Good, and remember to stay tuned. Like I said, we have more great interviews, just like Rick coming, and so we hope you'll be back with us in a few minutes. Hang tight. Well, welcome back. I had said we had some more great interviews, and we do, just like our last one. I'm joined by Steve Jaguar, who is, tell me your role at Bridge Crew again?
I'm a developer advocate.
Developer advocate, who knew, at a developer conference. How does that work?
Surprise.
What do you know? So Bridge Crew, which is part of Prisma Cloud.
Correct.
When you were acquired during the pandemic, if I remember.
We're not all around very long. We came out of stealth. We were, I think that was during the pandemic, even just before.
Wow.
And then about a year into it, we were acquired by people we never met.
I didn't know when you were going to meet.
And then suddenly we're here at KubeCon, finally, and it's amazing.
It's an interesting path or leap over path or whatever it is.
Yeah, it's weird.
Well, tell us about Bridge Crew. We're talking about Chekhov.
Yep.
Tell us a little bit about what you all do.
Well, sure, I'll start with Bridge Crew. Bridge Crew is an infrastructure as code and cloud security solution, but it is founded on open source, which is the t-shirt I'm obviously wearing as a shameless plug. Chekhov. Chekhov is a scanner you can use for free that scans pretty much any declarative infrastructure as code. So that's a pretty wide range, isn't it? It's like Terraform. All the strange derivatives of that, like Helm and Customize, are covered as well. And that's kind of what we're going for, is make sure that we get as much of that as easy as possible for developers. I sound like I'm advertising now, but I've said it a few times today.
You probably have said this before, yeah. I'm curious, I started my security work back when sort of scanning, vulnerability scanning meant network scanning, right? What's different about that today in a cloud infrastructure stack, software environment? Or is it some of the same, just applied differently?
It definitely is some of the same. The advantages of infrastructure as code is that you can just do the whole of that earlier. You know what's going to happen because you've defined all of your interactions between your cloud resources, you've done it via Terraform, you've done all of your Kubernetes and applications via Kubernetes YAML manifests, so you know what's going to happen before it happens, or at least you should. Add into that container image references, both in Terraform and in YAML, and if you can scan those, and you have your vulnerabilities, then you kind of have all the information you need to do a very, very shift-left version of what we used to do.
Yeah,
so
it's interesting. And declarative environment is the big thing that's different, of course, than YAML and Helm and everything you used to define those environments.
We're defining the state, so why don't we check it? Well, why wait till runtime?
So interesting, developer advocate. Do you find that like platform engineers are often your entry point into an organization, or is it usually more developers, software architects?
Well, it's funny, it would have been a few years back. I think the whole DevOps movement means that I'm talking to a lot of multifaceted individuals now. Some of them are developers, some of them are developers who have gone into ops, some are true DevOps that are just building vast, complicated pipelines. So it's no surprise that right now everyone's talking about supply chain security, because the role has moved into the creation of supply chain almost as an internal product. And those tend to be the people that we're talking to, when we're not talking to security people, of course.
Yep, you do have to talk to them.
Unfortunately, yes.
Yes. So let's talk about supply chain integrity. Lots of examples. Log4j was we've always had supply chain integrity issues. It's just we know about a few because of how widely and widespread they're used. Log4j being an example. What do you think is, what are we missing about supply chain integrity that we really have to take more seriously as a development organization?
It's funny, what are we missing about supply chain security is kind of there's a lot of answers to that. There's some really great projects like SigStor, which is here, which is doing signing of all artifacts, and that goes back to sort of the SolarWinds style infiltration of the entire build process. That's something that we have to look at.
That's what most people don't realize. SolarWinds was an infiltration into the build, software build. That's where it
was
really started.
Very clever. So that's something that's gaining a lot of momentum now, but it's so complicated that we're just not at all there. The more short-term solution is things like what we're trying to do, is make sure that you can see your supply chain. So like, for example, something we just added to Bridge Crew is because we have all this infrastructure as code, all of this declarative nature, you can now see it in the tool. So you can see this is going to be your edge, and these are all the connectivities of all the resources you're creating as they go all the way back to where your vulnerabilities live. So if you need to search to see if you've got something like Log4j, and you want to know if it's accessible, that's kind of where we're focusing on now. And I'm sure we're not alone in doing that.
Well, it makes sense too. It's not just what you have or software decomposition, it's what's being used and what's exposed. And
what's exposed, yeah, it's about context. I think a lot of people can get really tired of looking at vulnerabilities.
We used to call them the barking dog, right?
Yeah.
You know, like I don't need another log message saying I have a vulnerability I don't need to worry about.
Yeah, it's funny. I used to work for a SaaS company and it was just, noise was a big problem. And certainly now tool fatigue, all of this is a problem that we're trying to address by making sure that, sure, we're going to tell you things are wrong, but we'd like to give you the information you need and the context you need so that you know exactly where your fixed location has to be to make sure that you feel like 99% safe.
I'm curious, I imagine you can play in a lot of different ways in the software development process, but is there one area where you tend to stand out more? Is it during the build process and doing scan, and as that environment's constantly changing, infrastructure as code? Is it assessing a current environment and understanding what you have and what's vulnerable? Is it maybe as an audit tool to look at third-party environments? I mean, where do you typically shine the best? Or is it something else other than that?
Well, I think originally we were a command line tool that scanned Terraform, but now I think where we shine the best is actually in the IDE. We have integrations for VS Code, and we have integrations for JetBrains, and the IDE now is very much like, I think it's a little bit like GitHub Copilot, where as you're creating Terraform or as you're creating YAML, there's a plugin there that's actually telling you, whoa, you didn't do this, or you're about to do that, or you left that unencrypted, or you don't have your CPU and memory requirements here. So it's giving you the information built into the IDE, so it's both secure, but for developers it's educational. And it's a very soft and gentle education so that they're not feeling like security.
So the light bulb in your code like the JetBrains does, not the, the klaxon alert.
Yeah. That's exactly what we're doing in JetBrains, and then in VS Code, it's a little squiggle. So you hover over it and you're like, oh, right. And in VS Code, we have the ability to even say, would you like me to fix it for you? And you say, okay. I like when people fix my code for me. And then you have more secure code. So you're like, all right. I mean, if everybody used checkoff and everyone used the VS Code and everyone did everything it said, we would never sell our commercial products. But that's never happened.
Yeah, I don't see that. I mean, let me know how that goes. Well, it's interesting too because there's so much shifted left. We talked about that in the security world and DevOps. You can't rely on the developer to do everything. They can't be an expert at everything.
Correct.
So shift left isn't just about putting on the developer's shoulders, solving all these problems. So building it into the process, into the automation, into the tools. We just want it to happen earlier, right, in the process.
Exactly.
So it really makes sense that you build it into an IDE.
Well, that's almost the most left. I mean, you're right, shift left is almost got a bit of a bad reputation because it sounds like we're dumping our security woes on the poor developers who already have deadlines and things to get done, which often have nothing to do with security. We really just don't want to do it all the way on the right. That's just the really expensive, low resource way of doing it.
It's where it gets compromised.
It's where you get compromised. Yeah, you don't want to go with, certainly defense in depth is required. Monitoring solutions are definitely required still, but you want them to do nothing. You want to make sure that you haven't got a very, very secure house, but left the keys dangling out of the back door, which I myself have done many times in reality. So we want to make sure that we kind of sprinkle it left as far as we can. I mean, I think the reality is the CI is like the ROI, that's the best place because
that is the meeting point, right?
It's the meeting point of everything. Ops people are familiar with it. If you make it simple like a GitHub action or a Circle CI orb or whatever it is you need, so that all the security just plugs in, then that's great. That's about as left as we would realistically expect people to go, but we're just trying to make it so easy that even that is a very minimal hurdle.
Where does your knowledge base of vulnerabilities come from? Are you taking that from logs from open source projects or documentation? Are you doing your own research, combination of both, or something else?
It is a lot of research. The Terraform, the initial list of Terraform ones came from our CTO, Barak, who just did a ton of research and created a ton of rules. Now it's coming from the community because we have a huge contributor base in Chekhov, so that's really great. People just check in slews of new rules that we didn't even really thought were good ideas. We have to approve them and make sure that they're sensible. Personally, I contribute to Chekhov, so last week I added rules for GitHub action workflows. And that was just pure research on abusing GitHub action workflows to find out what I could do.
You have too much time on your hands abusing GitHub workflows.
That's the fun part, come on.
No, actually, that kind of stuff is fun.
Yeah.
You know, kind of breaking things.
I did some pretty terrible things.
Did you? Okay. Yeah. We'll leave that for another show.
Yeah.
Not sure we have the proper rating for that, but that's a whole nother topic. Anyway, anything particular about the show and KubeCon that's, you know, ties into what you do and you're excited about, other than mass amount of developers? I guess there's 7,000 people here.
Yeah, that is good. On the obvious things of humans, wow.
Yeah, what do we do now?
What do I do? I have to learn how to talk again.
Yeah.
I think the focus on supply chain, I mean, that's where we're going. It's nice to see the confirmation that that's where we're all looking at right now. I mean, I was at the SecureCon, the Day Zero event before this started. Met a lot of great people, talked to a lot of people about what they're doing in terms of supply chain. And so it's sometimes you're operating not in a competitive way, like we're all security companies, but we all know each other. So we meet and we collaborate at events like this to make sure that everything we're doing, be it open source or commercial, becomes better for the supply chain security or security as a whole. So I really enjoy that.
Very cool. Well, Steve Giguere, thanks for joining us today. Have a great show, and hope you do well. It's exciting to be in person. Nice to see you in person too.
Thanks very much for having me.
So definitely check out Bridge Crew, Checkoff, and Open Source. A great name, too. Great writer, of course, as well. Thanks for joining us. We have more great interviews coming up. So don't go away. We'll be right back. Welcome back. As I said, we have more great interviews. I'm joined by Shahar Fogel, who is CEO with Rookout. Welcome.
Thank
you. Good to see you.
Being here.
I know you've been at other KubeCons and talked with Alan and folks here, and it's a good chance to meet you and chat. Well, tell us about yourself. Tell us about Rookout.
So Rookout basically is a developer-first observability solution. We enable engineers to get data from their code in remote environments in a click of a button without the need to write code or deploy application or even stop the normal performance of the application. So actually debugging in production or getting or understanding what's going on in these remote distributed environments in the new world that we're living in. That's us, great being here.
Tell you, it's nice. I was just messaging my spouse at home. It's nice to be at a developer conference with lots of developers here. It's amazing.
Definitely.
Kind of feel like we're back. The game is back, right?
We've been seeing it over the last few months. I think more and more conferences have picked up, but this is kind of the peak of what we're seeing so far. A lot of people, a lot of both vendors and new cool vendors, and also companies and people that are just coming to hear lectures and to see great solutions out there, and to kind of a lot of very high level of interest that we're seeing here.
So I want to explore this observability for engineers, for developers. It was a lot of observability solutions. Many products have been around for years that have kind of matured and evolved into observability, log aggregation, tracing, alarming, alerting, et cetera. So what's missing? What's the gap of, where did we forget about the developers and what do they need that was not being met?
So I think, observability, of course, is a very wide statement for something that have been existed for years. It started with monitoring for IT people back in the days and kind of evolved, but if we look at kind of the evolution of the market and the evolution of observability, mainly the prisma was around ops people, SREs and people that manage the infrastructure, and these were the kind of main personas that were targeted for with the solution that companies have built. So understanding kind of the infrastructure, nothing is on fire, nice dashboards, everything is green and not red, and with time, more and more granular data in terms of, you mentioned logs, metrics, traces, and a lot of great companies out here which is doing it. But if we're looking kind of last 2-3 years as we see it, new world, distributed, containerized, cloud native, this is what we all of us are here for, and especially Kubernetes. And a lot of solutions have been built for day one, for building the application, releasing it, and making sure it's running. But the engineers are kind of being left behind, the actual engineers, not the ones that are writing the business logic, not the post-sales and SREs, that they're still there, but they don't have the tools to cope and deal with the new world. Today, in the last year or so, COVID 2-3 years back, a lot of effort to build cloud-native solutions, distributed applications, and now when it's kind of day 2, where it's actually running in production with not only small startups, big enterprises are already adopting and using it, so it's there and it's running, but when something is happening and it gets escalated to engineers, tier 3, tier 4, they don't really have the tools to go about and understand what they need, because the lens of how you build a product, how you design it in terms of experience is not designated for them. Even if everyone's an engineer here, SREs and developers are kind of
different needs. I mean, different points
needs,
in the life
question, much
of the
more
product
dynamic nature. Every day it's a new challenge, new questions, new features, new bugs, whatever, and they need to get the data in a much more dynamic way. And no one is doing it. No one is giving them the solution that they need.
So there's a lot of avenues I can imagine you might pursue in this. No news that microservices and cloud native architecture is a much different approach. There's lots of things in the environment. I'll label it things, whether it's containers and microservices, service mesh, et cetera, that you're trying to understand and manage. Is it more about the software architecture of your application that it's running in? Is it more the infrastructure, the Kubernetes stack, and the other infrastructure as code that developers need to see into? Or might it be behavior of the application's data about what's happening inside, frequency of use? What parts of that are you working on
I think
addressing?
It's a mixture of the three things you've mentioned, and on top of it also kind of in-company practices, so how responsibilities are being managed within the company. So everyone's talking about shift left and giving more power to engineers, but you have the ops people there who are managing or owning the infrastructure, and then it's a little bit of friction, and they need access, and they don't give it. And next week, come in the next sprint. So everyone needs, everyone's getting more accountability, ownership, responsibility over the applications on one end. On the other end, there's a lot of frictions and roadblocks and dependencies within the organization, kind of the software part. That's one. Secondly, kind of the more technical part is that the notion of, it works on my machine, the old notion of, we build something big, we integrate with a lot of other pieces of code, we compile it, deploy it somewhere. Today is very different. The way you develop software, much smaller chunks of code, a lot of dependencies, APIs, service mesh, what have you. And then when it's being delivered to the actual environment, so the engineers are not responsible for allocating memory or RAM or inter-services dependencies and service mesh and kind of the whole infrastructure part of it. So they don't know if they have half a giga or 2 gigs of RAM to use, and some of the things that are doing are dependent. So and that's the second thing. And the third thing is around, again, the dependencies of how quickly can you develop? You develop, engineers spend, when they're, on their day-to-day, I think 60+% of their time is not actually developing, is not actually writing code and adding value to the organization, is fixing the bugs that they wrote 10 minutes ago or a day ago. So a lot of time is being wasted there, and there's a lot of shortage around engineering and engineering power, and a lot of engineering managers thinking about how do we optimize it, how do we produce better value from the manpower we have or the teams that we have. So lots of changes across the board, people, type of people, organizational structures, technologies, programming languages, Go, you name it, a lot of new challenges, and the matrix of building it all together and solving these challenges, at least for us, from our viewpoint, it's a new world. People need new tools to live with it.
Well, again, speaking of new world, now there's some solutions that are runtime observability. Most are aggregation of information. Obviously, it sounds like to do what you're doing, you're talking about runtime libraries or something that's built into software you're deploying, so a developer can directly see into what's happening.
Yeah, so basically our solution is an SDK. We run together with the application, and we instrument the code in runtime, like live instrumentation. Very deep tech elements of cybersecurity mindset in order to, most of the questions that we're being asked, the value is apparent. People see it, they get it. Okay, this is worth tens and hundreds of thousands of dollars for us in ROI. But security and performance, how does it impact, and all those type of considerations is a key element of how we're doing what we're doing. In terms of kind of the nature of the product, so you mentioned a lot of solutions out there, but they're mostly high level, they're mostly statistical. You cannot collect everything all the time, and talking to clients, talking to enterprises, I wouldn't name names of companies, but their observability bill is in the millions already. Their logging bills are skyrocketing, and they need solution, because you cannot really collect everything all the time. Besides the fact that it costs you a lot of money, besides the fact that it impacts the performance of the application, there's the logging FOMO, and you collect everything, and then when you need it, it's just finding the needle in the haystack.
Okay, you need the right things out of all that.
And again, there's a lot of analytical tools and stuff like that helps you, but for developers, and we talked before about the short attention span or the need to get quick answers, they need it now, they need it immediately, and they're not used to using analytics tools. And they're used to develop and getting data and seeing and understanding and doing the connotations together and move forward.
And how do developers get access to this information? Is it through their IDE? Is it through some console or logging? console or of some type,
so for
terminal?
us, the main platform is a SaaS platform. They're using us through the SaaS platform. Of course, we'll add along the way also IDE plugins. We have some CLI solutions and of course a lot of APIs to automate it, to use it through their platform. So we're, as I mentioned before, developer first observability solution. When we develop the product, we think about the business need, we think about the business pains, but our users eventually are the guys who are sitting there and writing code. So this is how we develop and think about how we add features and which capabilities we need to give them in order to make them feel happy and convenient with the way that they're using this capability. And looking ahead, 2, 3, 4 years from now, the developer first observability, and you're hearing it also, starting to hear it from the bigger players as well, that they reconcile that this is the future. And this is going to be the standard for them in any toolkit, like an IDE is, and a logging aggregator is, and observability solutions, so developers need this as well in their tool chain.
But I think you were talking about how things are different. I think one of the things that's also different is how you build products, especially building for developers. What do they want access to? APIs, not as a sort of outer way to peer in, but they want to be able to integrate it into something they're creating, an environment they work in, or maybe tools they're already using or things they've built themselves.
Exactly.
So it's almost like API first.
Exactly.
Right? Developer first.
They like to work in their code with APIs, in their terminal with CLIs. We need to give it to them, and this is kind of what we give them today and what we're adding along the way, and constantly thinking, developers, what do they need? How do we give them the ability to use it in a simple way?
Great. Well, it's exciting to talk with you, and I'm sure you'll have a good conference. It's the right environment.
It's an amazing conference. So far, it's half a day, but it's been, I think we've seen traction and traffic for like 3 days of all KubeCon.
Yeah, I feel like this half day is like most whole conferences.
Exactly. I told someone this is KubeCon on steroids. It's crazy. But
Well, wish you the best. Have a great conference.
Thank you.
Go check out Rookout and visit the site. I'm sure there are lots of good stuff developers can get access to. So thanks for stopping by.
Thank you.
All right, come back soon. We'd love to see you back for our next interview. And welcome back. Great to be having you join us here at KubeCon and Cloud Native Con. It's what an active environment. I'm joined by a friend from Lightstep. Good to have you, Ted Young. Not Ted Young. That's a friend of mine. Sorry,
no,
Ted Young. It
name.
is Ted Young. I have a friend named Ted Young from a few years back, and you're head of developer education, right?
That's correct.
At Lightstep. I'd love to talk about Lightstep, but I know you're also, what is it, co-owner, co-founder of
one of the
OpenTelemetry?
co-founders of OpenTelemetry.
That's exciting.
Yeah.
I mean, talk about what's fascinating. There's so many fascinating things about this. I use this as an example of how open source is transformed, where it really truly is open source in a community of vendors who are all adopting it.
Yes.
You know, rather than it becoming a product for a vendor.
Yes.
You know, per se. I'm curious, just to start with, why do you think that's happened? Why have vendors so openly, no pun intended, said, yeah, this is the right thing to do. This is not where we're going to differentiate. We're going to do things on top of OpenTelemetry.
Yeah, so I think there's a couple of reasons. There's reasons why this is really attractive for end users, but the reason why we were able to get all of the vendors and cloud providers on board was, I would say, basically two reasons. One is this is a telemetry project, so it's about standardizing the language systems use to describe what they're doing. And if you don't have a standard like that, then every company or project, including all the open source projects, has to go in there and provide their own instrumentation for every programming language and every major open source library in that programming language. And if you roll back time, it was possible to provide an observability tool kind of focused on one piece or a small subset of languages and libraries. Like, you know, I think New Relic got their start as like Ruby on Rails development. There's surely other companies that got their start on like Java Spring observability. So that world has now morphed into this world where everybody is running these large distributed systems made up of tons of microservices, all heterogeneous, all different languages, different libraries. The rate of library development and language development has increased. And so there's just so much software out there now. Every single project duplicating the effort of providing instrumentation and trying to keep up is becoming more and more untenable. So that's one really valid reason of like, let's stop duplicating all of this effort and instead combine forces and provide one single way for everyone to describe what they're doing. The other reason why I think it's valuable for vendors is everyone is going the direction of open source, and no one wants proprietary libraries mixing in with their application code. And especially for something like instrumentation, where it's a cross-cutting concern, so it's not just sitting in a corner, it's getting inserted everywhere.
Well, it's a library for
like
every instrumentation tool I need. Well, I don't want to do that, right?
Sprinkling instrumentation all over the place, which means if you want to change providers, you have to rip out all of that instrumentation and then replace it with new instrumentation before you could even try another provider. And so that's like a real pernicious form of vendor lock-in, which end users are just not interested in, basically. So that's becoming more and more of a sore point with end users, is having to do that. So if we develop a standard, then the competition moves to who can provide the best analysis, who can provide the best analysis tools to look at the standard data. So that's actually a very nice separation of concerns. Like, we standardize on how systems describe what they do, and then we all compete on who's going to provide the best analysis tool for that standard data. And that was like a trade-off everyone was willing to make. You don't have vendor lock-in anymore, but that also means it's easier to onboard new customers. So if you have faith that the tools you're building are the best, then it sounds like a good deal.
Let's sit back just for a minute. Maybe I should have asked first. Why don't you describe for everyone OpenTelemetry? How would you kind of break it down into what it does?
Sure. So OpenTelemetry is the telemetry portion of observability system. So again, one half of an observability system is applications, servers, hosts, platforms, Kubernetes, things like that, databases, all of these things describing what they're doing. So that's emitting telemetry data. That data then goes into like a pipeline, and then it eventually comes to rest in some kind of analysis tool. So OpenTelemetry is this telemetry portion, everything but the analysis. OpenTelemetry is all the different observability signals combined into one. Traditionally, you had this sort of 3 pillars approach where you had these siloed vertical stacks of logging and metrics and tracing, all totally separate from each other, which put a lot of burden on the operators trying to analyze that data because the data wasn't interconnected in any way. So if you're trying to correlate across all these different signals, you end up having to do that in your head because there's no ways for the machines to help you because the data's siloed. So OpenTelemetry takes a new approach to this, which says all of that data is going to come out in a single stream, and it's all going to be interconnected and correlated. So you can actually build a complete graph of what your system is doing, and then you can apply like statistical analysis and all this other stuff to that graph of data. So in general, it's kind of creating a technology wave in the observability world where you're seeing all these analysis tools go from being a single vertical to being more like an observability platform where they're ingesting metrics, logs, tracing, client telemetry, RUM, eBPF, everything coming into one tool that can then kind of like cross-index and find correlations across all these different signals. So OpenTelemetry is kind of like the first telemetry system to provide the data you would need to power one of these new observability platforms.
And I remember you actually subsumed or brought in open tracing as part of the larger effort.
As part of trying to develop a standard, it's there's this old game called like Katamari where you're trying to just roll everything up into a giant ball, and it kind of went the way of people converged onto 2 competing systems, Open Tracing and Open Census, which were very similar in many ways. They had some subtle differences, but they were more or less trying to solve the same same problem. But 2 standards is no standards, and so everyone realized that in order to really make this work, we have to combine these projects into one project. And so that's where OpenTelemetry came out of, the combination of taking the best design sensibilities from open tracing and applying them to the open census implementation, basically, combining those 2 things together to form a new project. And we did that. That was kind of the final key to bring in all of the people who hadn't been involved in one of those 2 projects. When they saw the projects had merged, that signaled to a lot of people this was really going to happen as a standard, and then a bunch of new people came in at that point.
A lot more behind, a lot of momentum.
Yeah.
Well, speaking of that, open source projects mature just like any other technology. I know you've had some announcements about OpenTelemetry and its evolution here at the show. Tell us about that.
Yeah, so I mentioned OpenTelemetry has 3 core signals: tracing, metrics, and logs. Tracing has been stable for over a year now. That's the part that everyone's using today if they're using OpenTelemetry. Just this week, we're announcing that metrics has now gone stable, and there are now release candidates for OpenTelemetry metrics available in a wide variety of languages. So I would be encouraging anyone who's interested in OpenTelemetry, interested in metrics, to go try those release candidates out and let us know what you think. And logging is going to go stable, fully stable, probably in Q3. Most of the logging pipeline is in place at this point. It's just finalizing our API, our logging API. It's kind of the last piece there.
Most developers are going to understand what you mean by stable when you talk about a branch of the code. sort of in layperson's term, what does it mean to a certain part of OpenTelemetry to reach a stable state?
Yeah, so one thing we really care about in OpenTelemetry is backwards compatibility, especially backwards compatibility at the instrumentation API layer, because observability is a cross-cutting concern, right? So you're going to put these instrumentation points everywhere. It's going to go everywhere. All of your code, including open source libraries. We've designed OpenTelemetry to work well as a way for open source libraries to instrument themselves. And so you're talking about millions and millions and millions of API calls everywhere. We don't want to break that. If we ever break backwards compatibility, that's going to cause horrible dependency conflicts for anybody.
Strand technology that
right,
can't,
because
can't
you're going to
upgrade.
be, you're going to be trying to compose all these libraries together, and if they depend on incompatible versions of OpenTelemetry, then that's not going to work very well. So we are very, very compatibility conscious. So we don't declare something as stable until we are completely certain that we are willing to support it basically for eternity. Even if we come up with some fancy new fangled way of doing it, that would show up as yet another new experimental signal, and we wouldn't mutate or otherwise affect the stability of what's already out there, and we would ensure that there's some way to then bridge over to the new thing without dropping support for the old thing. So that's what we mean by stability.
There's a lot of us that wish that others would do that too, because it is a hassle when APIs overturn and you have to go back and rebuild, rewrite code.
I actually think we've developed some best practices in that space, and we don't talk about that aspect of the project so much, but I think that's something, like you said, I would wish to see from any widely shared library to think more about how you architect what you're providing people so that you can continue to provide new features and change without breaking what people were already dependent on in the process.
Sounds like the subject of a really good book. I don't know if you're interested in writing one. But
well, I actually, I just wrote a report for O'Reilly, the future of observability and OpenTelemetry. So I got free print copies here, if anyone's watching Zach KubeCon.
Great.
And you can, if you Google around for that online, you can find a way to download that. We've got you can download it from O'Reilly's website or from Lightstep.
Cool, very good. Anything happening in the Lightstep world that you want to talk about?
Let me see. I think Lightstep is charging ahead with becoming a fully fledged observability platform. So we've been really focused on tracing and tracing-based workflows, but we've recently expanded into metrics as well. And so Lightstep's doing a lot of work to provide a sort of like unified experience across tracing and metrics. I imagine logging will get brought in at some point as well. I don't want to make any promises there, I'm not on the product team. But that approach of having the machines identify all the correlations for you. They can't find the root cause. That's the human still has to interpret what this information means.
There's a lot of work in that correlation, though.
Yeah, because you have this pattern of you look at some data, you make a hypothesis, and then you want to verify whether your hypothesis is correct. And if between making a hypothesis and verifying it, you have to go collect a whole bunch of data and sift through it yourself and look for correlations or signs or symbols, that really slows down how fast you can make a hypothesis and verify it. And so Lightstep really focuses on providing tools that shorten that process. Basically just immediately telling you, hey, this endpoint that's showing a bunch of errors, all those errors highly correlate with a particular Kafka node, or they highly correlate with a particular iOS version, or they highly correlate with a particular VM or a particular version of a backend service. Being able to see those correlations allows you as an operator to quickly get a sense of what's actually going on.
I'm curious, maybe it's obvious, maybe it's not. Why why is being such a big contributor, being a co-founder of OpenTelemetry, why is that important to a vendor company, to like Lightstep? Why would they spend all the money and time and effort supporting it?
Sure. Well, I would say like in Lightstep's case, as a young upstart company that's trying to break into this space, you want to prove to people that you're serious, not just about providing a product, but about like actually showing leadership in the industry. Ben Siegelman, one of the co-founders of Lightstep, designed the tracing systems at Google and wrote what's called the Dapper white paper based on that system. And basically all the tracing systems that have come out since then have been based on that Dapper paper.
Sort of the father of, or the origin story of
tracing. And so the next step after that, founding his own company, we wanted to continue with that leadership role in the space. So that's one of the reasons why it's important to us. The other reason is this separation just seems right. And if we could get everyone to work with us to make it happen, then we're moving from a world of vendor lock-in to a world where may the best analysis tool win. People are not worried about being stuck or having some painful transition to move from one vendor to another. And since we think we provide, some of the best analysis tools you can get, it's really beneficial for us to reduce the amount of friction that people have to go through when it comes to adopting Lightstep.
I think in the contemporary modern world of open source and kind of thinking about software differently, it makes all kinds of sense.
Yeah. It's also one of those things where it's kind of like, especially with any kind of analysis tool, but especially statistical analysis or machine learning, it's garbage in, garbage out. Like the data coming in has to be really high quality data. And we think by developing that as an open standard, you can get a lot of subject matter experts to come in. You can get a lot of end users and developers feeling like it's worth their time and energy to instrument well and to participate in this process of describing what systems are doing, because they're not just losing that effort to some vendor's implementation, right? Like this is something they can take with them through the rest of their career. So our feeling is that by doing it through an open standard, the end result is just higher quality data coming from more data sources. For example, databases can now start emitting open telemetry data. You're even seeing like cloud providers, like hosted services, starting to emit open telemetry data. So now your traces go from your client to your applications to your backend services, now to SaaS services that your backend services are built on top of. And you're able to get a trace entirely end-to-end, including those services that are being operated by other people, because they can now send you a stream of open telemetry data.
Well, very good. Exciting news, exciting progress, and I think it's exciting for the whole industry. It's great to see what open telemetry, has done and will continue to do. So congrats to you for having the forethought to co-create such a project. So Ted Young, who's with Lightstep and also the Open Telemetry Project, thanks for coming by. Hope you join us again.
Great, thank you very much. Great to be here.
You bet, thanks Ted.
Yeah.
Be back, please join us for some more interviews. We've got some great folks coming up. Good stuff, man.
Hey, man. Thank you.
Enjoyed it.
Yeah.
I'll connect with you and see if we can have you on a few panels and some other things we're doing.
Yeah, absolutely. Yeah, anytime.
Love to do that.
Thanks.
Yeah, that was awesome.
You're free.
And I am sincere. I think open telemetry is one of the best examples of what can be done through open source.
Yeah,
so.
it's definitely a much more pleasant open source project than some of the ones that we've done in the past.
That's good. That makes all the difference, right?
Politics, low drama, space, so everyone's really appreciative.
That's awesome. Very cool. Have a great show.
This is Digital Anarchist.
I have the great pleasure of being joined by Lynn Marks. Lynn is Senior Product Manager of Online Fraud Prevention with Imperva. Welcome, Lynn. Good to be talking to you.
Thank you for having me.
Absolutely. Well, let's start out. Tell us a little bit about yourself and tell us a little bit about Imperva.
Sure. So I've been in cybersecurity for around 5 years. And like you said, I'm a senior product manager working on the online fraud prevention solution. So that encompasses solutions that bring visibility and control over bot and client-side attacks. Now, Imperva is able to help customers protect their data and all paths to it. And even though we did start off in the WAF market, we've truly evolved, and our products are now able to protect customers from all aspects. So all the way from the edge to the application, to the APIs, and any important traffic that you might need to protect as well.
Right. The security landscape is getting bigger and bigger. It's a lot of bases to cover. Well, we're talking about bots, excuse me. And we know you've just issued your Bad Bots report. But let's start out with talking about what do we say? I mean, the bot world is not, static. It's ever changing. It's our job to keep up with it, maybe try to get a step ahead once in a while. What kind of trends, what do you see that's happening?
Sure. So in the last year, we've seen that bad bot traffic continues to rise and also become more sophisticated. And when we mean sophisticated, so these bots are behaving more and more like humans and are trying to evade standard security tools. So one, really staggering statistic that we've realized in the last year is that bad bot traffic now actually was a record-setting 27.7% of all global website traffic. So, over 25% of all traffic that we see on the web is now bad bots, which is really mind-boggling. And this is 2% more bad bots than the year before. We've also seen that evasive bad bots, so those more advanced bots that are trying to evade the security tools, now make up a really large majority of the bots that we're detecting. So they make up 65% of bots. And this really goes to show why it's important to have a security tool in place that can detect and mitigate these bots, as they are becoming more advanced and are able to wreak more havoc on organizations.
Are there particular types of bots or sources of bots that are on the rise or becoming even more prominent in terms of a potential threat towards us?
Yeah. So when you're thinking about bots, you really have to remember that they're trying to take advantage of your intended user flow. So they're going to try to attack like your login page or your credit card page. And that's really why it makes it so difficult to actually catch them and differentiate them from the real users and the bots. And we've seen that account takeover, so attacking the login page and trying to take over attacks, is consistently the number one attack that we've seen. And then followed by price and content scraping and scalping. In case you don't know what scalping is, the other term for it is inventory hoarding, when bots are trying to snag up hot ticket items.
I think the bots are going after the same electric vehicle I'm trying to get because you can't get them. Anyway, a whole nother topic. It's interesting too. One of the trends that I've heard, Lynn, is that we've been saying that it's you can recognize bots that are non-human and then things that are sort of falling in the gray area. Might be a person, is a person. What I've heard is the trend is more towards the automated bots being more human-like, being harder and harder to detect whether they truly are automated versus a person.
Yeah, exactly. Bots are continuing to evolve so that security organizations like Imperva won't be able to catch them. So we've seen like more and more bots, let's say, cycling through IPs so that you can't just use very simple security rules by blocking IPs. We've seen them like changing their identities and characteristics, switching up their user agents, or trying to use user agents that we would more commonly see real users actually use. And really using whatever other tools they can have at their disposal to mimic real human behavior as much as possible.
Interesting. Yeah, I'm curious, there's the obvious just nuisance part of bots, right? Like taking up resources of 27.1% is bot traffic. That's kind of a pain. But there's much bigger impact. You talked about account takeover. You talked about inventory hoarding. Some of that's end user customer impacting. Some of it's business impacting too. That's lost revenue, customers that you have to deal with. Maybe even fraud, the cost of fraud, and paying that back. Are there other kind of business impacts that people are seeing now that either rising in prominence or maybe new things that we're seeing?
Definitely. We've seen that organizations being hit with like very large bot attacks can see infrastructure costs be increased. And they could actually pretty much being hit by a DDoS attack because of these bots. You can also end up having, of course, like reputation damage from your inventory hoarding use case, where customers are upset that they're not able to buy the products that they might want to buy. Of course, customers can then also have a more degraded experience when actually trying to use the websites or applications if bots are hitting the infrastructure. And a couple of interesting ones that I think people don't think of right away are that also some metrics, internal metrics, might end up being skewed, like marketing metrics or usage metrics could end up being skewed. And you could also end up having increased credit card processing charges. There was this really interesting situation where we saw where there was an online beauty e-commerce site, and they were having bots testing the cards that they got online for their validity. So what they do is that they make really small purchases with a lot of different credit cards to test which ones are still active and which ones aren't. And then, of course, they can go sell the valid ones or use them, to buy bigger purchases themselves. And what was really interesting about this is that it wasn't actually the security team that realized there was an issue, but it was the finance team that came to the security team because they were having increased chargeback fees being levied on them by the credit card providers. And I think that's a really good example for how bots can truly have an impact, not only on the security team, but on other departments in the organization as well.
We seem to be in this phase of we've invested heavily in defense, right? Trying prevention from seeing things happen. But now I think there's more of a how do we be proactive approach. You can't prevent everything, but also you can be more proactive and also know that breaches or those kinds of activities are going to happen. What are some of the things that either you recommend or you see your customers doing that would be more in the proactive, preventative nature?
Sure. So I have a couple more general recommendations and also some more technical ones. I think a couple things that are really important. Number one, pay attention to publicly available breaches. We've definitely seen that following large data breaches that, of course, then the credentials or maybe credit cards are then published online, there is a spike in the bot attacks that we're seeing. I think it's also really important for security practitioners to truly have a good visibility to all of the assets that they need to protect, and also to the pattern or characteristics of how their different assets and data is being accessed. So figure out the ways that people and attackers are trying to get access to your assets and what the general characteristics of those usage are. So maybe the rate per second or rate per minute or the geographies of your users. And you really need to have a baseline of how your different assets should behave and be accessed so that if there is a spike or the behavior changes, you're able to pinpoint it and start investigating if you have an issue. Now, of course, you probably predict that I'm going to say this, but I think it is really important that organizations that are dealing with bot attacks should implement a dedicated bot solution, because trying to deal with bots yourself, you're going to end up spending a lot of time trying to investigate exactly how they're hitting you and what are the different characteristics so that you can create rules. And especially if you are being hit by these more advanced bots, you're not going to be able to use rules where, let's say, you're just blocking a specific IP, because if a bot operator realizes you're blocking their IP, they're just going to cycle and start using a different one. Mm-hmm. So using a dedicated bot solution really helps you make sure that your employees don't have to spend so much of that time doing that work themselves. Now, if we're looking at more of the technical recommendations, of course, making sure to use secure protocols. Don't just use HTTP. Of course, use HTTPS. I think it's also really important to make sure that you implement an audit trail where you can track changes or access not only to your infrastructure, but your applications and APIs as well. So you can know what is the typical behavior, and if someone who shouldn't have access to your infrastructure or your applications is all of a sudden seen through the audit trail, you're able to quickly and go and investigate it. Another really important piece is to make sure that you are compliant with any compliance frameworks that your organization might fall under. So for example, if you work with credit card processing, you'd want to be compliant with PCI, and really make sure you're reading all their different recommendations, because they cover a lot of different types of attacks. And take it seriously when they give you these different recommendations, especially for the more new and evolving types of attacks like bots. And I guess my last recommendation is related to network security. And make sure that when you are setting your permissions, only limit access to the IPs and the geographies that really have to have access to your assets, and don't give hackers that extra opportunity to gain access by not really limiting and locking down your assets.
I know too, you all had an announcement around API security, and you have API security, you have web gateways, you have DDoS protection, you've got a number of things for cloud native kind of applications, network data security. So, the bot protection is one element that fits in that entire ecosystem, which of course is one of the big strengths of Imperva. That I'm sure you get to talk with a lot of the other product leaders in your organization about those things. Now, you had this report come out, and I'm sure folks can grab that from your website. Before we do, is there anything else you want to add or want to say just in terms of Imperva's approach? And I mean, I listed kind of just a laundry list of capabilities, a few product names I'm aware of, but anything else you want to share with us about Imperva?
Yeah. So, at Imperva, we've really focused on protecting the applications and protecting the data. But, when we're looking at it holistically, we really believe that protection of the data is really the root of everything that we do. Because even when we are protecting your application, in reality, what we really want to make sure is that malicious actors or hackers aren't able to access any sensitive company data or sensitive customer data. So really, our products are built to help customers protect what really matters, and that's that underlying data that cyber criminals are after.
Excellent. Well, folks, best thing to do in terms of next steps, go check out the Imperva site. I mean, you have a lot of information there, the reports there, other things. Good place to go next. Product solutions, things like that, right? Imperva.com, correct?
Imperva.com, yes. Over there, you'll be able to see lots of data sheets, lots of videos, and more information about all of our solutions. And you'll also be able to read our newly published bad bot reports and learn, all of the interesting trends that I went over with you today, but also lots of other additional and interesting facts and trends that we've seen in the last year about bad bots and how they are impacting organizations.
Awesome. Thank you. Well, appreciate it, Lynn. Thanks for coming by. Lynn, again, is Senior Product Manager for Online Fraud Prevention with Imperva. I hope we come back again soon.
Thank you.
You bet. Thank you.